Hi everyone, and welcome to the stream. So today we're gonna try to recreate this masterpiece over here. In case you don't know what this QWOP game is like, you're basically this Olympic runner that has to win the race, has to go 100 meters. And basically, it's very hard because these keys Q, W, O, and P control like the leg joints and the arm joints and actually just the thighs and the calves apparently, so only parts of the leg. And at some point I was able to get some more meters from this, but now it looks like I'm quite bad at it. And basically, the whole point of today is to try to recreate this thing from scratch, to learn how a game like this is made. And I have a little bit of a to-do list here on the left where I divided what's going to happen today, my implementation of this. It's probably not the way that this game is implemented, but I wouldn't know how that one is exactly implemented. But I know that we will get something very similar to this. And I'm not gonna make a person running. I want to have something a little bit more funny, and maybe we're gonna have some kind of animal doing the running. I thought maybe a moose because I'm in Finland, and Finland has a lot of mooses, a lot of moose. I guess that's the plural. But I don't know. Maybe we think about something else. In the morning, I was talking with my wife, and she was suggesting maybe a giraffe is more funny because it has long legs and long neck and something. So maybe we support both of them. Who knows? The last part on this to-do list will be whatever comes to mind and whatever you guys write in the chat. And it may be quite interesting to have this kind of game play itself. So maybe we're going to implement also some AI capabilities. If you're watching this not live, but a recording, like a video on my channel, then maybe you want to skip to the end to see the end result if you're interested in following along. I will probably put a link in the a pinned comment in the comment section with the timestamp where a good demo is. But it's gonna be a long one, so I have reserved 8 hours for this today, and it's great because I haven't been coding for many months now, so it feels cool. Okay, and some people in the chat, good morning everyone. Why I left Romania? Well, actually, I left Romania to be with my girlfriend back then, a long time ago, and I came here to study my master's. So I did my bachelor studies in Romania, in Timișoara, and then I went to Finland in Joensuu to the University of Eastern Finland, and I did my master's studies, then my PhD studies, and whatever. But basically, main reason was she was in Finland, and I came here. All right. Well, that's enough demo of the idea of today. We start with this basic HTML page, which is empty, and it's just an empty file somewhere on my computer here. So we will begin to write basic HTML. I will check the chat from time to time and read your comments, but I will also focus on coding, and it's unscripted, so we'll have to figure out things on the way. I've done something similar to this a while ago, so I'm quite sure the techniques we use today will eventually get something to work, but I haven't done exactly this, and last time I've tried this was I think maybe 3 years ago or something. So it's just kind of, yeah. Yeah, um, true, but I'm not a programmer. I'm a teacher, so I teach in class normally. We do have also remote teaching at work, but I normally prefer to teach live. This YouTube thing is just a hobby. So, head section of HTML page. Let's give this a title. Let's just call it QWOP clone, like this. And in the body, I'm going to work with the canvas element today, so it's going to be a canvas application. Like so. There's no intro song, and actually, I'm gonna slim it down a bit. I'm gonna try a kind of a very short version of it, which just says coding with Radu in the next few videos that I'm gonna publish. So hope that's not gonna disappoint, but all the videos will have a link to the extended version of the intro song with all the characters, and I think it's longer, quite long. So if you miss it, you can watch it, but now it's gonna be some slimmed down version of the intro song in the next few videos that will come on the channel. All right, now JavaScript. And let's give this canvas a size. Maybe, let's see how it goes with 900 pixels in width. And 500 pixels height, something like this. And let's give some styles here to the body. I'm gonna make the body black. And the canvas white. I will refer to it by ID here. So my canvas CSS will have a background color white. Let's refresh this page, and yeah, that's what we get. I think it's decent. Let's center this canvas in the middle of the screen here. I'm going to just put here text align to center. Hello. Yeah, that's good. And I'm gonna have my developer tools open, so I usually open them with F12, but there are several shortcuts and you can find them here under more tools, developer tools. It's very important to have these open because otherwise when you have an error, you don't know if it's an error or if your program is just behaving that way. Okay, good. Now, first thing we will do is implement a kind of particle physics system. It's something I've been using very often on the channel in different things like in the flag simulation. It's this Verlet integration technique for doing particle physics. And it's really basic, but it's surprisingly useful in all kinds of applications, including what we are going to build today. So if you understand this one well, then you can find a lot of uses for it. Okay, so let's do that in a separate file. I'm gonna start to organize my code because it's gonna be a big project. So I have to think a little bit about structure, not just slap code everywhere. And let's make a physics class in physics.js. So our physics class We'll have a structure, I think. Or maybe we don't even need the constructor. Maybe we just, or we do. It should store whatever particles we give it to operate on. So let's pass here in the constructor the particles as a parameter and store them as an attribute like that. All right. And these particles, we are going to be moving them according to some rules. They will be moving according to some rules, gravity, whatever other forces act upon them. And we also want to draw these particles. I don't know if I want my physics class to do the drawing, but maybe it would be kind of too much over-engineering if I implement another class for doing all the displaying stuff. So I think that our physics class will do the drawing as well. And let's put here the context, the canvas context where we will be doing the drawing for quick access as well. And we will have a method here for updating. And this is going to loop through the particles. It's going to update the particles and it's going to draw them on the context. So something like for each particle P of the particles in this object, it's going to update them. So our particles will need to have an update method and also draw them. Now I'm going to put initially these next to each other, but I think we'll need to separate them at some point because particles will affect each other and we'll need to handle collisions and some things, maybe not collisions, but these constraints I have mentioned there. You'll see. And here we pass the context for the particles to use when drawing themselves. So let's write our particle class that has these methods here, the update method and the draw method next. Like so. And these eventually need to be added to our index HTML here. So let's include them. Like so, and another one for the particle. Difference between self-taught and the degree programmer. Yes. I think. Do you want to learn more about that? So we are making this QWOP-like clone. If you don't know what QWOP is, it's this game that became famous in media a while ago, a long time ago. I would say maybe 10 years ago or even more, where it's really, really hard to get this guy to run. And it's not easy to implement this. And you have to control his thighs and calves with these QWOP buttons. So I'm going to do something like this, but different. Yeah, happy you liked the self-driving car course. Yes, a lot of things going on. And we begin with basic physics where we have a particle system. So our particles, they will be able to update themselves somehow according to gravity initially, and then we draw them on this context. So now we're moving on to make the, to implement the particle class. And the particles will be initialized at some location. Let's let's pass here to this constructor the location where this particle is going to be initialized at. Let's just write here loc like this. And we will need to store this location inside of the attributes of the class. So this, and let's put the attribute for location is equal to the value of that. Now, the way this Verlet integration framework works when you implement physics is that it calculates the next location of the particle according to its current location and its previous location. So it kind of predicts the next location based on where it was, where it is, and some forces that may act on it at this exact moment. By default, we consider here that the old location where this particle was is the same as this current location here. So let's say old location is also equal to loc. And now these need to have all an update method and a draw method for our code from previously here to work. And this draw method takes a canvas context as a parameter. I forgot to initialize it here. Right. And we can draw them as simple circles for now. So let's just do CTX arc. Let's begin path first. And then arc at this location. So this is going to be an XY location. This loc X, this loc Y. And let's just give a hard-coded value for how big the dot is going to be. Maybe a radius of 5 is enough. And a full circle, so start angle at 0 and end angle at 2 pi. 2 pi means 360 degrees, but it's in radians. And most functions in most programming languages work with radians by default. Hi, QWERTY. I prefer class, but that's just because I've used a lot of Java in the past, and somehow I like the syntax, and well, it's here. Yeah, Adobe Flash games, well, they were something. I used to make those. I used to have a job making those as a freelancer about 14 years ago. They were good times. I had a lot of fun making those. And now when this HTML evolved and this canvas element can do pretty much the same things as Flash could, I'm happy. But of course, I also lost a lot of familiar things when I was coding in ActionScript. Then again, it was always quite similar to JavaScript, so not a big harm, really. Okay, so now we would really like to operate with some higher level functions here, because these points here, they will be considered as vectors in our code. And we will do simple vector operations like adding two vectors, subtracting two vectors, and stuff like that. So I'm going to create here another file, let's call it math.js. And here we're going to implement all the math that we are going to need to make the movement proper. So first thing we do is, given a location and an old location, let me try to draw something here in PowerPoint to get the idea of what this is going to be. So this is going to be our particle. Let me just make it black here, like so. So this particle has a location, you can see it somewhere here on the screen, but it also has an old location, a place where it may have been before. In the constructor here, we initialize both of them to be the same. So basically, in the first scenario, very first moment, this is what we will have. But eventually, some things will act upon these particles and move it somewhere here, and the old location is going to be here. Then the particle may move because of something, maybe gravity pulls on it like this, and then this old location becomes what it was previously, and so on. So the reason why we use both of these locations here, the old location and location, is because we will compute a velocity vector, a vector that tells us what is the direction and what is the magnitude of the movement. So let me try to emphasize this a bit more like that. So our vector here has a direction, this angle that the arrow is pointing at. It will change depending on where the old location is and the current location is. And to get this vector, we have to do a difference between these two locations, the current one and the old one. So that kind of function is nice to implement here. Otherwise, we have to always write the x of the point minus the x of the old location of the particle, the y of the current location minus old location, and so on. So repeating yourself like this 2 lines instead of just writing subtract is a bad practice because we're going to use these things a lot. If you don't know what I'm talking about, if you think that these topics are complicated, I have videos designed for this. So you can find on my channel in these, I have this playlist with something. Where is it? Can't find it. There should be the one with the, oh yeah, the Math and Code Fundamentals playlist. So you can learn here the 2D vectors. This is pretty much everything that I'm going to be doing today, but it's really well presented. And we're also going to use the trigonometry. And I'm quite sure we'll use also linear interpolation at some point. They're all useful. Very sure we're going to use the Pythagorean theorem as well. I don't think we'll need these other 2 things. Who knows? But these things, if you're watching this and you're confused by what I do at some moment, watch those things. They are supposed to clarify the same things that we are going to be doing today. So let's get this velocity vector by subtracting from the 2. And I'm going to just write here velocity is going to be subtract. And here we have to subtract from location, the old location. And this subtract method is the first thing that I'm going to add in our math.js. And it's very simple. So it's a function actually, because math is not a class here. But location A and location B, like so. And what we do is we return a new location where the x is going to be a.x minus b.x, and y is going to be a.y minus b.y. Simple enough. So that's how we get the velocity here. The next step is going to be to calculate the new location by adding here this velocity here. So now we're predicting the new location by adding the velocity to the current location. And we're going to get some new location somewhere here. So basically, we're kind of predicting the future, so to speak. So we go here and write new loc is going to be add to this location the velocity vector that we just calculated. And we need to implement this add next. So in math, I'm going to copy this and I'm going to call it add. And this minus here is going to be a plus. And the only reason we are doing this is so that the code is more easily readable here. And you know add is not a normal add because you use plus for that. So it kind of implies that it's something more than just values. It's two-dimensional values in this case. But of course, these could be also extended to 3 dimensions if you want with XYZ, and you could use some libraries for making 3D version of this. Oh, hi, Frank. Hello. I saw you're making shorts recently. Maybe I should make those as well. My next few videos will be kind of short ones in comparison to what I've been doing recently. I'm kind of tired at the moment and I'm taking it easy. So they are shorts even though they have the regular landscape format, but short meaning like 10, 15 minutes or so. Okay, so yeah, great. We have now our velocity. We have added it to get our new location right here. And this is the moment when other outside forces can act on this as well. And by that, I mean anything. And at the moment, we have just gravity, but you can imagine here wind and some other things. The whole point is that when we have this current location here and we want to predict the future one, we do use the previous location as a reference. So this velocity that we calculated, but we can use any other force as well, like maybe this gravity here. If we add both of them together, then our new location is going to be here. The dot here didn't just move in a straight line, but it was also pulled down a bit. So this is what will give our simulation this kind of realistic effect of gravity on the particles. So all we need to do is here, after we calculate this this new location, we actually add something more to it, maybe a g or something. I'm going to write here at the top a static variable called g. And this is going to be a vector typically. So on x, it's not going to change anything. It's going to be 0. And on y, let's just give this a value of, I don't know, 3 pixels and see what we get. So here we add this location and the velocity to this location, but we also add the g. To the result of the other one. And I realize now that this is not good. I wanted to say physics here. So g, the gravity, is not part of the particle, doesn't belong there. It makes no sense, but it's part of the physics. So here, physics.g there. And now the new location is going to be as in my drawing here. It's first added the difference between the previous location to the current one again, and then gravity for now as the only force acting upon this. So that's how you get the new location here. And what you need to do after that is update the current location to this new location and the old location to the current location. So we do this first. Old lock is equal to this dot lock. So what happens now is basically this is moved where the dot was previously here. I just move it to the side a little bit. And then this one has to move to the new location that we calculated here. So we replace its old location and current location. So that's it. And to draw and see something, we will need to, let's stroke it for now. Okay, so this is a basic physics engine for particles using this Verlet integration technique. So the reason it's called that is just that you don't give it the velocity as the parameter here. You're computing the velocity from the difference of the current location to the previous one. I think that this should be exactly what we need to do. And let's next define some particles, give them to our physics, update them to see them on our canvas. So here, let's get a reference to the canvas context. Like so. And particles, let's just say 1 for now. P, new particle, and maybe 100 pixels at X 100 from the left and Y 100 from the top. And let's give this particle to our physics class. So here it's expecting an array of particles, so many of them. And I'm just going to say here, physics is new physics of an array of P. At the moment, it's just one particle there, but there could be many that we give at start. And now I'm going to tell our physics to update on this canvas context, like so. I think this should do something. Let's go to our application and refresh. And we have an error. Apparently, the context is undefined somewhere. So I'm going to go to this physics update. The particle updates, the particle draws. The physics also needs... Okay, here I'm passing the context to the update method. I think this makes a bit more sense. Because the physics shouldn't need to know the context. It's not really the drawing part. It's not an element of physics. We don't need to store it here as an attribute. So I'm just going to pass it here as a simple parameter to this method. Now refresh. And this is the particle. Nothing amazing yet. But what we will do is move this particle according to the gravity. So we will have to update this multiple times. Like, let's update it again. We have 2 calls of update here. Refresh. And you see it drew it again because we are not clearing the canvas between them. And let's do it again. It drew it again a little bit lower than the difference that we got previously. And that's how gravitational acceleration works. When you have an object here and you drop it, the moment you release it, it's floating there. And it slowly starts to speed up. So if we're gonna copy this multiple times like this, then you will see the object speeding up. I'm not animating it at the moment. I'm just showing you the trace that it's leaving because I think it gives a little bit better intuition how this thing works. And the particle now has no horizontal movement, no horizontal movement at all. But it could have. So at the moment, this old location is just basically forced to be the previous location. But if we say the old location comes from the location x minus 10 or something like this, and the y is going to be the same as the location y, so coming from the parameter, that means that 10 pixels to the left is where the old location is in the beginning. So we have this scenario where the object is moving horizontally, perfectly horizontally, and this length, the magnitude of this vector is 10 pixels. Now, let's see what we get as the trajectory for this new movement. I'm going to save this. I'm going to go here and refresh. And you see, object starts to move like that, but because the gravity is also affecting, it starts to curve downwards. So the movement is becoming quite realistic, so to speak. Now, you could continue copying these things here, updating many times, and then you get this trajectory mapped out even more. But I'm going to start animating this. So we will begin our animation loop and say it's going to be a function called animate. And we will use this request animation frame method that will pass here animate. So what will happen is that this function is going to call itself again, and then it's going to call itself again. It's going to call itself again. Typically, this is called recursion when a function calls itself. Here, it's actually calling itself with a delay, and you will find a lot of people calling this something else because this request animation frame will call it again so that it gives about 60 frames per second. That's something ideal in making simulations, games, and stuff like that. So it's different than just doing this, which would be the definition of recursion. But this would make your computer burn. I mean, it's going to make an infinite loop at the moment, and it's going to call it as fast as it can, not with this 60 frames per second, which is really slow according to what the computer can do. So let's leave this there, and I'm just going to call here update once, because this is going to loop forever. Now, we defined this function, but we never called it. So I'm going to say here animate, and refreshing this. It went quite fast. Every time I'm refreshing, this drawing is going on. And because the canvas is not cleared, it leaves the trail. Let's slow down things a bit. I'm going to make the gravity here much weaker, maybe 1 pixel. So now the horizontal movement is much stronger, and the gravity is accelerating. Eventually it's becoming fast, but now you can kind of see the animation better. Let's make it even weaker, 0.1. Too weak. 0.2. Okay. So hope you got the idea of how these particles move. Okay, looks like Frank is popular. I don't have. No, I don't have Udemy courses. I made the self-driving car course with Udemy in mind. I wanted to post it there as well. But then, just as I was about to do that, they made a limit that I think it was, I don't remember exactly, but they made a limit so that free courses could only be um, maximum 2 hours long or something. And I didn't want to ask any money for it. So I gave up on publishing it there. But I still posted it on, I asked the guys at Free Code Camp to host it there. Yeah, maybe it's like that. If you also remember 2 hours, but it wasn't before. So when I made the video, I made it. When I made the course, I made it with Udemy in mind, and I made also some exercises to give as practice, and some of the um, some of my scripts had Udemy mentioned and so on. So it was extra work, and then I ended up just scrapping everything there. Uh, I haven't taken any course on Udemy. Sorry, Frank, but I do see your things on YouTube, and I think that you probably have good things on Udemy as well. Okay, let's clear the canvas now. So, not leaving this trail anymore. 0, 0 is the top left corner, and whatever is the width and height of the canvas. So now you see that particle going down like that. I don't think I've been to Brazil. I haven't been to Brazil. I'm probably gonna visit someday. I think I've heard nice things about it. But I've been to nearby places like, well, I've been to Mexico, Ecuador, Panama, I think. Anyway, they were just short visits, like conference trips or things like that when I was doing research. I'm happy to hear. Yeah, I put quite much effort into that course. The neural networks weren't that well explained in it, but I plan phase 3 of that course to really focus on neural networks and explain why they work. Phase 2 is going to be something else. It's going to be, we're going to make the car drive on real roads. Like it's going to connect to OpenStreetMap, and it's going to you can have the car drive in your city, for example. I hope to get that ready for the summertime, but recently I've been quite lazy. There is link in the description with the game. I'm not gonna demo it anymore. So the particle movement is actually done. So I'm going to mark this in this to-do list as completed. And we are going to start adding constraints. Particles by themselves are not going to be very interesting, but constraints will be things that keep the particles always a specific distance from each other. You can think about them like rigid segments. Some people call them sticks. I call them constraints because it makes, in this section, we are going to keep the particles on the screen. Now this particle is going down forever. We don't want that. And then we're going to start to make our character out of these many particles and sticks between them that always keep them at a certain distance from each other. In this section, we also make sure the particles don't go off screen. Yeah, there is a link in the description. So I'm going to talk about these things as segments. When we have two particles, here, and they are going to be connected by something rigid, this is what I will refer to as a segment. Next. And when we define a segment between these two particles, it's going to have a length. Maybe this is something like, I don't know, 200 pixels. And anytime the particles move, maybe you punch this particle to the right like that, and then this one, gravity affects it like that, or something. If this distance is now more than 200 pixels, maybe it became 400 pixels. Meanwhile, what we have to do is constrain these particles to keep the same distance to each other. So what we will do is we will move this one to the left, and we will move this one to the right. Like this. So this distance here is still going to be 200. We have to move this one in this direction 100 pixels, and this one in this direction 100 pixels. So basically something like this. Something like that. Now, this 100 pixels here comes from the difference. What is this current distance here? Minus the distance that we want our segment to be. When we defined our segment, this length here is a property of that segment that should not change during its life. It can move, rotate, spin around, but it should still have 200 pixels in length. And the difference between these is going to give us how much these have to move inwards or outwards. Maybe we have a situation where these points are compressed, something like this. And now they need to be moved outwards a specific amount. So this is what we need to implement next to get things to proceed to the next level, so to speak. Okay, if it's not working on your phone, then let me just demo it one more time. And I haven't, this is not my game. I think you can find here information about who made it. But it used to be really popular. You have this Olympic runner guy that you control his legs, his thighs and calves with the QWOP letters, and you have to make him run forward. And it's really difficult. And it used to be a very popular thing long time ago. And I thought it would be interesting to implement something similar, but I'm not gonna do exactly that. So we'll see how it goes. Okay, let's implement our segments. So the segments are going to be in their own file, segment.js. Let's include this file also here so we don't forget next to the particles. Like so. And our physics should know not just particles, but also segments there. So I'm gonna have it store also the segments. They are rigid, they shouldn't allow, okay. They shouldn't allow their length to change. And here, same kind of syntax. I'm using this class segment, and the constructor is going to take two parameters. The first particle, where the segment starts, and the second particle, where the segment ends. Now, you can choose to call these whatever you want, like start, end, something like that. But I prefer short variable names, maybe A and B, and I know that they will refer to particles. You can also call them PA, PB, or particle A, particle B, something like that. Maybe this is a little clearer because in math we called A and B points or vectors. And if you read the code here and you see A and B, you may think that these are locations, points, or vectors, not particles. Remember, particles have two things. They have the location and the old location, and the way to update themselves. So, yeah, let's have here particle A, particle B like this, and store them as attributes. Okay. Now, let's have also a way for these to update and to draw. So it's going to be a similar scheme as here. And draw on a given context. This is going to be a line from the current location of the particle A to the current location of particle B. So CTX begin path, CTX move to part A location, and line to part B location. So now we have the segment and we have a way to stroke it. Let's not have it do anything on update yet, but go to our index.html and define another particle. Maybe this is P1 here and P2. Let's put both of them in this array, P1 and P2. P2 is going to be somewhere to the right, maybe 200 on X, but the same Y value. Now, if I'm going to refresh this, you see two particles that are heading exactly the same way, basically. And just to make things a little bit more interesting, and it's a temporary thing, I'm going to change it soon. I'm going to pass here the delta x at the initialization. So we will remove this later. But basically, I want to pass a delta x value that here, when we defined our particle, we hard-coded here -10 for the old location. So I want this to be a parameter. This is going to be a value here. And back in our index.html, this delta x is going to be, let's say, minus, just a second. Okay, let's put plus here so that we have -10 as before. So -10 here and -5 here. And this is going to give us our particles moving a little bit differently because one of them is moving faster horizontally when it's initialized than the other one. I don't like that one of them is overtaking the other. So I'm going to flip them around. I'm going to put here -5 and -10. I think it's just easier to explain how this new thing with the segments is going to work if they don't cross and make something confusing there. So, two particles and they're moving nicely. Let's draw the segment between them. So let's initialize the segment first. So let's call it S is a new segment between P1 and P2. And our physics has an array of particles and an array of segments. At the moment, just one segment, this S segment there. But an array, because it's a general way of implementing this, we won't have just one of them. So yeah. And now in the physics, we go through all the particles, update them, and draw them on the context. And we can do the same thing with the segments as well. So we go, let's call this segment S, and it's also going to be able to update itself and draw itself. So going back to our application, refresh, and we get an error. Yeah, move to and line to methods, they need the X and Y specifically as two parameters. Now you see that segment that is essentially a line connecting the two particles, but it's not doing what I wanted it to do. It's not keeping its length. So that's the thing that we implement next. Yay, mastering the canvas. Hello. Yes, so let's do that. Let's make sure that whenever the particles move, the segment between them doesn't change its length anymore. I think first thing we need for that is a way to calculate the length when the segment is initialized. So here we define the segment between P1 and P2. But we don't know what's the distance between these. I mean, sure, it's 100 pixels. It's the difference on X here because Y is the same. But this should work regardless of your parameters here. So I'm going to go here and calculate this desired length of this segment here. And it's going to be the distance between the location of particle A and the location of particle B. I can write these just as so because the parameters here are the same as the attributes assigned to the class, so I don't need to put this in this case. Now this distance function is the Pythagorean theorem. It's calculated using the Pythagorean theorem. And you can implement it a number of ways. I showed previously that video I have on the topic. So the distance between A and B is going to be the square root of the sum of the squares on X and on Y. So you can use the math library, for example, for square root here, and then say a dot x minus b dot x squared. You can use maybe the exponentiation operator. And then the same thing on y as well. If you don't want to use the math library, you can also avoid that using the separate operator as well. So here you get basically the hypotenuse in a triangle where this is the horizontal difference and this is the vertical difference. And square root is just raising this value to the power 1/2. So if you want, you could implement this without the math library as well by just raising it here to 0.5. It's the same result, no matter how you implement it. There is also a hypot method in the math library that helps you here. So you don't have to remember even the formula. You just pass the difference on X and the difference on Y, and you also get the same result. This one actually does even some clever things when the values are very big, or yeah. So up to you what you want to, how you want to implement this. And I talked about variations in that video I showed previously in the Math and Code Fundamentals playlist. Okay, so this gives us now, when defining the segment, its desired length here. The length when we created it. But now when we update it, we will get new lengths, because you see here this line is growing, and every time it's not the desired length, the 100 pixels that we had here in the beginning, we need to fix it. So let's calculate what is the current length, the one that it has at the moment, depending on particle A and B's current location. So to calculate that, we need to get we could get that as the current distance between the current location, like that. But I would like to use vector subtraction again, as we did before. First time when we implemented this vector subtraction, we saw that subtracting one from the other gives us this vector, basically. The length of this vector is the length, the distance between the points, but it also gives us the angle, and that's important because we will have to fix this to find these vectors to move this, no matter what is the initial orientation. So subtracting doesn't give us just the current distance, it also gives us the direction component of the vector that tells us how we should move the points to fix the problem. So I'm going to go here and say, let's say, maybe we call this sub for short for subtraction. Subtract. And here we put this part A location and this part B location. So this is going to be the vector between those two particles. Now, from this vector, we can easily calculate the magnitude. So that's the distance, the current length. And we can do that with a new function that we have to implement in our math. let's just call it magnitude of this subvector that we just calculated. So magnitude is a really easy function to implement. We just go here to math.js, and it's not similar to add and subtract because it only has one vector as a parameter. It's the length of that vector, the magnitude of that vector. I'm going to copy one for reference here and say magnitude of A, and all vectors are actually positioned at the origin. So I'm drawing it here at the point of application. That's the correct definition. But this vector and this vector are equal. It doesn't matter where I'm moving it in the screen. The thing that defines a vector is basically its angle and its length. And it doesn't matter where it appears here, it's always the same vector because its angle and length doesn't change. So typically these are considered to be in the 0, 0 point in the origin. And here we have another small triangle again. So we can use the Pythagorean theorem and get the hypotenuse with the square root between those things. But it's easier than that because, because the, how to say, we don't need to have a difference anymore. I mean, if the center of the vector is at 0, 0, the tip x minus 0 is just the tip x, and the tip y minus 0 is the tip y. So it's similar to the distance function here, but easier. It's just returning a dot x squared plus a dot y squared, and then the square root of that. Like so. You could also have used here the same distance formula from previously with the 0, 0 point as the second parameter. It's the same thing. So you could have written this return distance of A and x0, y0. Some people implement it like that. It's going to give you exactly the same results here. I just stick to the previous implementation. Okay, so back to our segment. We subtract, we get the difference vector, this sub, and then the magnitude is this. So we can now compare this magnitude to the length that it should have. And let's actually log these values. Let's log this dot length and mag and see what we get in the console. Let's refresh. And I'm going to scroll back up. You see 100, this one stays the same always, because this is going to be the length that we want our segment to have always. But here, this value is constantly getting bigger and bigger because originally one particle is moving faster than the other, and it's going to keep moving like that. There is no friction or anything like that at the moment. It's just the initial difference in location and the gravity that is affecting on them. So this second value needs to be squished back into 100. But they both start at 100 here. Now, because I'm printing this after the movement here in physics, you see we first move the particles and then update the segments, which also does that. We already have moved the particles, first one by 5 units and another one by 10 units. So the difference is 5. And that's why we get here our initial printing already bigger than what it should be. So, yeah. I did. Oh boy. Wow. It's possible. It's possible. I mean, I speak with Finnish people quite often and I hear them speaking English and I might have adapted to that. I also speak a bit of Finnish, but I'm not an expert. How I prevent getting overwhelmed. I'm not overwhelmed by this because it's not uncharted territory. I've done similar things and I know what to expect. I know how long it's going to take me, and I'm quite familiar with the errors that can come and would be surprised if something is really, really hard to figure out. Yeah, I guess that answered John and basic coders question there. I also don't care so much if somebody comes in the comments and says, "Hey, your structure is horrible and you should engineer it differently," and so on. Uh, I can try if it's a good argument, but it's a fun project. I don't want to be too serious here. Hmm. Um, well, some things would scare me a lot. Like, I don't know. Let's see. Yeah. So, back to this. You see, the length, the magnitude of the vector between those two locations is growing, and I don't want that to happen. I want it to always stay the same. And now we're going to apply this technique where we move both of them half of the difference. So in this case, here this is 105. It needs to move 2.5 pixels towards the center. So from both directions. So 5 in total, the difference from there. And let's just go step by step here and figure out these things. So I'm going to go and first define this difference here. So the difference between the magnitude and the length there. And I'm just going to say diff is magnitude minus this length. So now we get 105 minus 5 or whatever, minus 100, which gives us this 5, or whatever is the difference from what is currently and what we want it to be. And now we have to move these particles, have this difference in the direction of the subvector. So we don't care anymore about the magnitude of that vector. We just want to know the direction. And there is a technique that is called vector normalization, which means that no matter what is the length of that vector, a normalized vector is going to be the same vector, the same direction of the vector, but with the unit distance. So unit distance is just a fancy unit magnitude. It's just a fancy way of saying that this is a 1 pixel vector. It's so small that you couldn't really see it. It's just 1 pixel, but I had to give it some size here to figure it out. So you find that by dividing its components by the magnitude, you scale the vector by the inverse of its magnitude. So we need to find a way to scale vectors. That's one new function that we implement. So scaling means if we scale this vector by 2, it's going to become twice its size. If we scale it by a half, it's going to become half the size. And if we scale it by the inverse of its magnitude, like maybe this here is 100, if we scale it by 1 divided by 100, the inverse of the magnitude, then it's going to be just 1 pixel in length. So that's what's called normalization, scaling by that one specific value. And scaling is really easy. So let's go in the math here. And I'm going to copy this add here so that I don't type everything again. And I'm going to scale a vector, let's just call it v here, by a number, a scalar, a value, like 2, a half, whatever. So let's just call this one scalar to know that this is not the xy component. And we return here v.x multiplied by the scalar and v.y multiplied by the scalar, like so. And the normalization, the normalize function for a given vector v, we don't need to pass this scalar because it's going to be the inverse of the magnitude. So let's just get the magnitude of our vector v, and then return scale v with 1 divided by the magnitude, like so. So 2 new helper functions here that we are going to use. First thing I want to do here is normalize this subvector to just have a unit vector. It's easy to work with unit vectors. You can scale them, for example, with half this difference in one direction, half the difference in the other direction. And it's going to be very convenient to work with them. So let's just say here norm for normalized vector of this subvector is normalize sub. And now we have to scale this normalized vector by half of this difference in one direction and then the other one in the other direction. So what I didn't mention yet is that this here, you can scale it by 2 and then you're going to get double its length. You can scale it by a half, you get half. But if you're going to scale it by negative values, it goes in the other direction. So here, this one goes in the same direction as the subvector, but this one will go in a negative direction. So we use a minus there. And both of them need to be half of this diff value that we are calculating here. So let's try to figure that out. And I'm going to say this particle A location is equal to, and we have to add to the current location the scaled normalized vector scaled by half the difference. So let's add to this particle A location scale of norm half the difference. So difference divided by 2. I think this is going to solve this problem. It could be also that I've switched A and B around. Sometimes I do this mistake in my mind. Let's see. And for B, it's the same as here, but minus diff divided by 2 because it's in the other direction. And if this doesn't work, it means that this minus and plus are switched. So this is the kind of answer to your questions from previously. It starts to become overwhelming and you can make mistakes. But if there's a mistake here, it's probably that, or some typo or something. So I'm used to these things, and yeah, let's see if it works. So I'm gonna go here and refresh, and it doesn't work. It's going really crazy. Something horrible is happening. Let's do this like so, minus and plus here. You don't need to type plus there. It's just implied, but I put it just to make it clear, and refresh. And something happens. They both move at the same rate pretty much. Because they are connected. Let's try something a little bit more interesting. So here when we're defining the particles, we use this delta on x, but let's actually just call it delta and use it on y as well. So what I'm doing now, I'm reverting the code a little bit. I'm actually going to remove this segment from here, so we don't have the segment anymore affected by physics. But I don't like it. Other direction here for the y. Let's put a minus. It's too much. So instead of 10, I'm 5 and 10, I'm going to put minus 3 and minus 5 now. I want them to move a little bit different. And this is just a quick hack. We will remove this delta eventually. But you see, one of them is kind of jumping a little bit, and the other one is jumping even more. So now when we re-add the segment here, you can see a little bit more of an interesting effect happening, because one of them wants to go upwards a little bit. So it induces a spin, a counterclockwise spin on this segment that we defined here. And you see these values here, they are not exactly 100, but they are almost 100. It's 100.0 something there. This is not easy to explain why it happens, but it shouldn't happen. So it could be because of floating point differences, but I think the main reason is this magnitude is calculated before we fix it. So if we would do this again and calculate the new magnitude, let's just call this sub 2, and mag 2, after we have done the fixing, this should be 100. It's still not exactly 100, but it's very, very close, like 100.00000 something. And here 99.99999. This is before we fix, and this is after we fix. But you still get some issues with floating point values when you do calculations with floating point values in JavaScript. It's kind of unavoidable. So it's almost going to be 100, but with such accuracy, humans cannot detect anything and screens cannot make this difference. I mean, pixels are pixels. Yeah. For some changes here, you may see difference because of this anti-aliasing, but Yeah, it looks good. So it looks exactly like how it should be. And we are not done with the constraints. I would like to make it so that there is a floor here and that the particles don't go down through the floor. And then these constraints are going to be done. Now, let's see. Do you have more comments there? Normalize function, it's just useful because I don't want to type here scale sub by 1 divided by mag, which is a little bit more cryptic. And when you do linear algebra, normalize is a name that means scaling by the inverse of the magnitude. So people know what it is. And you should too. It's a very common thing. And in the machine learning course that goes on, we often talk about data scaling, data normalization, data standardization. Um, Normalization is everywhere in machine learning. You won't escape that. So I'm using these terms even though I typically hate using too much terminology because it can be scary. But it's just scaling by the inverse of the magnitude of the vector so that you get a unit vector. And true, you can implement this here a bunch of different ways. Like, I don't know, maybe you can just scale and without the normalization and combine here the difference with the magnitude somehow in one giant parameter there. But I like this. Normalization means you have a unit vector that has a 1 there, so it can be multiplied by anything, and it becomes that magnitude that you give as the other parameter here. And here we're moving one of the points uh, in the direction of the subvector by half the difference, and the other one opposite direction by half the difference. So code makes sense like this. Otherwise, if this becomes something combined with the magnitude, then it becomes difficult to interpret this line. It becomes quite a lot of complicated stuff. So personal preference, but you can implement a bunch of different ways. And yeah, I could use sometimes, where am I using arrow functions? Where should I use arrow functions? Because you mean here? Okay. So maybe you mean something like this. So maybe you mean that, and I think here I wouldn't need to use this anymore because it has access to those things. Let's see. Sure, it works. And not repeating this is okay. It's there is always the kind of pros and cons for everything. And I just have personal preferences for many things. It doesn't mean that I don't see benefits of other things. But here, for example, at least the way I wrote it now, it added the level of indentation here. So before it was the same as this one here, basically all the code inside the update function was on this line. And now in this new version, it moved everything towards the right a little. So even though I don't have to type this anymore, the code still tends to exit towards the right with the same kind of amount, or maybe a little less, because some of these had two thises, but yeah. Anyway, sure, arrow functions are good, and it's good to know they exist and what may be some of the benefits. I'm not sure if this is exactly how you wanted me to implement it, but thanks for the tip. Okay. So we have this segment there. Let's make also the constraint so that you're welcome. Let's make also the constraint so that let's make also this draw now, since we are here, have a kind of similar structure, and remove this from here. Then again, I think you could remove this at this level even without an arrow function, even with the classical function notation. No, because then this refers to the function itself. Yes, you're right. You're correct. Okay. But because they would be in the same scope here with part A and part B, I think it would work. So if this would be no, because here I'm assigning this function. Let's just try it real quick. Yeah, it still works even with traditional functions, but that's because I'm writing these in the same scope as part A and part B, so I don't need to use this. And it's true that it can cause some that this causes some issues, but I stick with the arrow functions in this case. All right. Now we have this. Let's make a floor here, and I'm gonna draw this floor somewhere. Floor y. I just want to define the y value of the floor. And this is going to be my canvas height multiplied by 90%, 0.9, something like that. And let's draw this floor somewhere. So CTX begin path, move to 0 floor y, and on the right to my canvas width and floor y, and stroke. Now this should be line 2 here. And this is where the floor should be. And I'm going to use this floor y. I'm going to pass it to the physics. Maybe it's not the best thing, but I think the physics should know where the ground is. So let's put here floor y, the y value of the floor. Floor y is floor y. And when we update these, we update the particles, then we fix also these segments. But if the particles go below floor y, let's just force them to be floor y. So I'm going to say let me think. Updating the particles. After they move, they should be constrained before the segments are tried, I think. Or after. Let me see if there is a difference. So if we do that before the segments, then the segments may move the particles again below the thing. Like the segment moves down, then the top particle wants to move down even more, but the bottom one is constrained already. So yeah, what can happen is basically, let's say this is our segment and this is now the floor here, and situation like this might happen. So in this case, I'm going to force this particle to be here because I don't want it to go under the floor. Then this segment is now smaller because it should be this length. So the update of the segments is going to make this one go up and this one go down again a little bit to fix its length. And now this is below the floor again. So I actually want to update these constraints for the floor after fixing the segments as well. Let's see. I'm just gonna try. So, but I want the particles to update. I want the segments to update. I want the things to be constrained. And then I want to draw everything because now I'm updating this, I'm drawing it, and then things change, but it's drawn where it's not supposed to be. So yeah, so I'm gonna separate this code for drawing the stuff and for updating the stuff. Like this. So this is where the drawing happens. And this is where updating happens. And now I'm going to constrain the particles, keep above the floor Y. So again, I'm going to loop through all the particles. And I'm going to say if p dot location y is greater than floor than this floor y, then p loc y is equal to this floor y. And now we get that. And this is particularly interesting now because many things start to happen. Like, can you notice there is a small bounce going on? It's not easy to figure out why. And I think the reason is when one of these particles goes down, and we now move it up so that it's not going to, how to say, it's not going to be below the floor anymore. It did move up, but its old location may be still below. Let me think. No, no, that's not the reason. I think the reason is we have now a situation like this, and then the fixing the segments will move like, okay, this is moving down, it's moving like this. Then fixing the constraints is going to move this up here. And now this segment is smaller. So in the next iteration, what will happen is this cannot go down anymore. It actually will still go down a little bit like this, but this is also going to go up a little like this. So this movement up from this point, I think, is what makes the bounce happen. Yeah, I think that's probably the reason. So a little bit hard to explain, but basically the points are traveling down like this. One is now below. So fixing these constraints here is going to make this point up like this. In the next iteration, this length is too short. Things still move now, like maybe this point wants to go down, so this becomes really, really, really short. But then this length is going to fix itself. So it's going to move this one like that, and it's going to move this one like that. And the end result is that this point here, wants to go upwards. And that upward movement from this point is going to pull this other point with it up. It's really not obvious why this is happening, but it's definitely a bounce there. And it's a nice effect for many scenarios. It's not really a rigid body anymore. It's kind of a springy effect to it. You can implement this springiness also by yourself, like specifying how much springiness you want. Let's see if we need to do that later on. But anyway, I think that we are now done also with these constraints, and we can move on to do the skeleton design, which is going to be how we want our character to look like. So these constraints I have marked as completed. And now we do this skeleton design part. Yeah, let's check the chat real quick if anything new. Thanks, birthday is tomorrow, but today is the coding event of the birthday. Okay, Yoni is here. Wow. I am on vacation. This is a vacation project. Yoni is my actual student from here. So I am on holiday this week. I took a week off because I had to do some extra work previously and I had some kind of free days. Thank you, Radu. Salad. Okay, I think caught up with the comments in the chat section. So let's design our skeleton for the thing that we do today. And I want the creature not to be humanoid, but maybe we start with the human and update it to be like I want to do a moose, an elk, or maybe something more funny eventually. But yeah, skeleton design. And it's really tedious to start to make the skeleton um, with coordinates. I can do that. It may take a lot of tries. I could also implement a quick editor, a segment editor, by clicking on the canvas and creating points, selecting points, maybe making links between the points like these segments. I'm not sure what I should do, but I don't want to overcomplicate things. And if I make this kind of skeleton designer tool next, it may delay my progress today quite a lot. What do you guys think? Should I make some editor for our segment, for our character, um, to design the character, or should I just guess coordinates and type in to get something? No comments, so maybe I just try with the coordinates. At least for now. If it becomes too tedious, then maybe I make some kind of character editor or... Ah, I'm torn. I don't know what to do. Okay, since somebody wants the character editor, maybe we do that. I mean, maybe I could design it easily, but then if I want to try different characters easily, it's gonna be a pain to do this again. I could also try parameterizing things, but do we get one more vote for the character editor? If we get one more vote for the character editor in the chat, then I'm gonna do the character editor. If not, then I still think about it. It's just that if I'm gonna type the coordinates of all these particles to make the human-like skeleton, it's gonna take a long time. And then if I'm gonna want to change it into an animal or something else, it's going to also take a lot of tedious, time-consuming stuff where I have to guess coordinates. Character editor designing it also takes a lot of effort, but then making new characters is trivial. Let's make it like that. I take Radu's comment as a kind of a... yeah. Let's do that. Okay. Thanks, Radu and Rajesh. Now I know what to do. Yeah, so I'm gonna actually do something here and update my to-do list. So skeleton design first is or let's call it skeleton editor, and then 4, 5, 6, 7 updating this to-do list. And now this skeleton design is here. Okay, so let's, I mean, skeleton editor is here. So now let's move on to 3, skeleton editor, and see how we do that. So we're gonna add mouse event listeners for clicking on this canvas. And I'm gonna use the same canvas for the editor, I think. Because we won't need the mouse for anything else. There will be keyboard listeners for the movement. So let's just do that and have event listeners for mouse move, mouse down, and mouse up. So let's try. I'm gonna make here a function for a file for the editor. Like so. And let's include it in here. And I will just write functions here. So I don't think I'm gonna make this as a class, or since we are using classes so much, let's have a class. Skeleton editor. The constructor is going to get the canvas element on which we do the editing. And let's save this here and get a reference to the context as well. I want to assign the event listeners to the canvas, so I need that too. So getting the 2D context, and it's going to have particles and segments as well. So this particles is going to be an empty list, and this segments is going to be an empty list in the beginning. But then if I'm going to update this, ask it to redraw the particles and the segments that we have created with the editor, then let's have a draw function that I'm going to copy everything from this physics like so. So these are called particles and segments. So these are things that the editor will generate, the particles and the segments. And now let's initialize this skeleton editor here somewhere. So editor is equal to new skeleton editor on my canvas. And when we animate here, we could draw it somewhere. So we can, CTX needs to be, it's the one from its attributes from the canvas. So this CTX here and this CTX here. And draw doesn't need parameters here. So skeleton editor draw. This should work. Let's see. No errors here. Of course, the editor now doesn't have any particles or segments into it. Those need to be added somehow through mouse interaction. So let's make a function here, a method, and it's going to be a private method where we add event listeners to the canvas. And this happens when we define our skeleton editor. So adding event listeners, and our add event listeners method is going to add to this canvas. It's going to add this. Let's put the mouse down event listener, and the function. Let's write arrow function, an event, and just log this EVT here for now. Typo there. Okay, let's refresh. And if I click somewhere here, I get my mouse event. I don't need these updates anymore in the console. Let's remove them from segment here because I know they work. And now if I click somewhere, I get this information about where I click. So we need to get the mouse location inside of the canvas somehow. And we do that by using this I think it was this rectangle function. What is it called? I have to look it up. I don't remember. But yeah, get bounding client rect. I could have found this through documentation, but Stack Overflow is your friend sometimes. So it's important because the canvas in our page here doesn't start at 0, 0 here. It's somewhere in the middle of the page. So I need to know the left and even this top small margin there to get the relative mouse location. Otherwise, this event client X and client Y will not work. So just to see what I mean, if we put here client X, client Y, and refresh, and now I'm clicking close to 0, 0 here, I get 100 something and 8, because 100, it's this part from here. And it would change, like if I move now my developer tool to the right here, and I click again in the top left corner, now it's 10 and 10, because that's how many pixels are here to the side. And now this distance is bigger, so it changed to, I guess, 40 and 8. Yeah, let's make this. Yeah. So I want to remove this padding here. And that's what this function here helps me do. So let me add to this skeleton editor a function for getting the mouse position here. And I think that I'm just going to write it inside of this method. Or as before, it's just fine. It can be actually a private method as well. It's a helper function, and I don't know if we need this to be outside the editor. We may move it eventually to some more common place. But now this is just fine, and we don't need the canvas because canvas is part of the attributes of this class. And the event is something that we need. So here, console log get mouse position from the event. And what basic coder was talking about previously, I can still use this inside of this arrow function because it's an arrow function. So this should work. And now if I refresh the page here, thank you, people. Now if I refresh this and I click close to this corner, aha, get mouse pose is not defined because I need to call it as a private method. Now I get 0.3 and 2, so very close to 0, 0 in that corner. And it won't matter anymore where anything is. This is going to be 0, 0 pretty much. So it's reducing that left and top margin. The reason why these are floating point numbers and not exact values, even though everything is a pixel, is that think about having maybe odd number of pixels horizontally on the page, and you have to move it half from this side and half from that side, so then the pixel gets halved somehow. It can be even more tricky, but yeah, if you don't like floating point values, then just round those, maybe like this. I usually do that because human eye anyway won't be able to tell much difference there. And now you get nice numbers there. Close to 0, 0 here in the, I can't click exactly there. And on the right, it's going to be close to 900, 500 there. Okay, so now what we do when we click down, we create a particle in the editor here. So in the skeleton editor, instead of logging this coordinate, we're going to create a new particle at this location, at this X and Y location. So we say this particles push new particle of, let me put this on a new line, of the location coming from the mouse. And now when I refresh this and I click, the particle is there. It's not affected by physics because these particles that I'm creating here inside of this character editor, they are not sent to the physics class. So physics uses just these two particles from here and this segment from here. But now we have particles also inside of the skeleton editor, and these are like floating in space. Nothing is affecting them. No gravity, no movement, no nothing. They never update because we never call update on these particles yet. Right. So thank you. So we have now a way for creating particles. We would also like a way for creating segments. And this can be a little bit more tricky. I'm not sure what is the easiest way to define segments between these particles. It's tricky. I don't want to have so much effort on the person who is creating these. Maybe I'm going to have our system so that we don't draw just individual segments, because it can be really tedious to connect each particle with another thing. But we connect with the previously drawn particles automatically. That would be interesting. Let's see what we get. So we add a new particle here, and let's add segments as well. So we go through all the particles and we generate segments to all of them. This is going to be before we actually add our new particle here. So what I'm going to do is I first define this new particle. Yeah, let's go here and say new particle is equal to new particle at this location. And now it's not yet inside of these particles. So I'm taking all of the particles from there and I say this segments push new segment between new particle and P, which is one by one all of the particles existing there. So I make all possible connections basically. And here, after that, I also add the new particle to our particles list, our particles array. Now, if this works, the segment was created there, and now another segment is created there, and 3 more segments are created there. And every time I add something new, I'm adding to this complex shape. Now, this would be a very interesting thing to see in practice. Let's see. Let's try to add this to our physics particles. So physics, particles. Is there an add all thing? This concat, I think. Physics, particles, concat, physics. No, skeleton editor particles. So I'm combining the particles from physics, the ones that are still falling down, with the skeleton editor particles. And I'm gonna copy this for the segments. And after I run this code, physics should start affecting on these things that I have drawn here at the top. Let's see. Something bad happened. Let's try again with just a simple segment like this. Aha, okay. When we create our particles, we have this delta thing that I was experimenting with, and now it's undefined. And when we create these new particles in the skeleton editor, I don't add any delta there. I'm just gonna set it to be 0 by default, so the particles will just fall down. Yeah, this is one of those hard to figure it out. So, okay. So now we have a way of connecting whatever we draw here to the physics engine that we wrote previously. Now this thing, what I'm doing now, basically would need a button. Something like press the button for adding the character into the simulation. Something like that. But yeah, so I would like to next start drawing things like this could be the leg of some person. The thing is, I don't want the other leg to be connected to this one. I would like to start a new shape. And now this logic of connecting everything to everything else is pissing off. So I need a way to stop a shape from let's call these kind of bodies something. Let's call this a body, or I'm not sure what the best name for it is, but we have particles, we have segments, and we have created some kind of rigid body here. So that thing I want it to be over with, and I want to be able to make a new one here or something else. Oh, wow, some crazy stuff is happening. I think when we have many segments like this... Oh, okay, it's interesting. Seems to be quite stable, actually. Mm-hmm. Yeah. Let's go to our skeleton editor and say that we are going to do that. Bodies. I don't have a better name for it. Objects. I don't know, because body is the body of the character that we will build. So let's say objects. Maybe it's better. So this object will be a collection of particles and segments. And maybe when we right click, we add body parts. Yeah, but it's kind of long, isn't it? Okay, this is actually called skeleton now, because later I want to add some drawings or some visuals to how the character looks like. So skeleton, bones. How about bones? Like, if this is going to be the thigh of the leg, and now imagine the previous drawing there, and this is going to be the calf of the leg, and maybe here at the bottom you can have the shoe. So try to imagine all the things that I drew together like that. So maybe these could be bones. Yeah. It's complicated. I would like them to connect in some specific ways. And if I draw them individually, then I still would need a way to. I don't want to connect to all of them. Here, like, let's say I want to draw the bottom part of a leg. Maybe it's going to be something like this. Now, if I want to make the shoe here, I would like to connect to these two nearest neighbors here, not to this one and to that one, all these other connections. And I think that connecting to the nearest two neighbors is enough. Like here, connecting just to these should be enough to give rigidity to the structure. This is kind of like extra thing here, I think. I could also make it so that I hold some keys on the keyboard, which should be the ones to connect to. It's becoming complicated, and I wonder if I should just make it so that, uh, yeah. Let's just add right click, and with the right click we make the segments, and with the left click we make the particles. It's easier, I think, and it gives us full flexibility to design whatever we want. I just don't like right click very much. And I don't even know how to do it. I think I have to do this context menu thing. Right click. Yeah, I think it's this one, and have to add this prevent default. Okay. So in skeleton editor here, let's add to this canvas an event listener for context menu. Let's make this an arrow function for consistency. Let's add an enter here. Close the callback function. And here we need to prevent default. Otherwise, we get this menu appearing. You actually don't see the menu. I think my screen recorder doesn't get it, but it's that thing with the save image and whatever. So it's annoying. And actually, it also clicks, right click makes the menu appear, but it also clicks. So it conflicts with the mouse down event from here, I think. Let's try this and prevent default. And can we get the mouse location from this event? Let's see. I hope. For right click only. So yes, looks like it works. But I don't want this mouse down shouldn't trigger. Let's see if click is different. Yes, so now with left click I'm adding particles and right click does nothing. At the moment it just lists the coordinates here in the console. So what I'm going to do is remove this part with the segments here. We just add a new particle here. And this one, with the right click, we have to implement some kind of logic, like get nearest particle from mouse. If selected, deselect, otherwise select. If another particle selected, connect to new one that we just clicked. So this would be the logic. Selecting points, if something is already selected and you click on it again, it deselects it. If something is selected and you click something else, it's going to add a link, a segment between them. So that's what happens there. So we need a function for getting the nearest particle to the clicked location here. So let's just say, let's pretend they are here, nearest, get nearest particle to the mouse. Then if this selected, we are going to need to store the selected particle somewhere, is equal to nearest, this selected particle is null. Otherwise, if this selected particle is null, this selected particle is nearest. Else, it means selected particle is something else, not the nearest and not this one. So here we add a segment. So this segments push new segment between nearest and this selected particle. Okay. Let's call this nearest particle. Like so. This is overall the logic, but we still need methods for getting the nearest particle to the location. Let's put here this particles as a parameter to this. We may use this get nearest particle function elsewhere. Right. From the given particles here, select the one nearest to the mouse location. And then this selected particle can be null in the beginning. And when we draw everything here, if this selected particle is something, then I'm gonna emphasize it somehow. So I will say this selected particle emphasize on this CTX on the canvas. Let's start with this, making particles able to emphasize themselves. Emphasize, this is gonna be another arc, but with fill. So it's gonna have a fill. The selected particles have a fill. And de-emphasized particles or selected particles now have a fill. Okay. Now, that's okay. And get nearest particle. So this is a function that we need. Let's just add it here, same as the other one, even though these are so general things that we may use them some other place as well, like getting the mouse position or this. We may move them elsewhere. But let's have it here for now and say get nearest particle from a list of particles according to a given location. And what we do is we calculate the distance from the given location to all particles in the list and select the one with the minimum distance. So it's live and the recording will stay also on the channel, probably in the live section. So distance to all from that. P of particles. Let's say P log is the particle location, like so. And distance between P log and log, this is going to give us the distance between the location we clicked to each particle one by one. Let's store this in D. And if this D is less than minimum distance, something that we initialize with something really big, maybe, I don't know, max safe integer. Every time we find a smaller one, we update minimum distance to this new D that we found, and we keep track of this particle that we just found. So P. And here we return nearest. Okay. Let's see what we did. Refresh. And now I click. A particle is added. Another particle, another particle, another particle. And now I right click. One particle is selected. If I click it again, it's deselected. Selecting, deselecting, selecting, deselecting. This is with the right click. And now click. Oh, I left clicked by mistake and now I created two particles here. It's one next to the other. But right click here and right click here. It made the segment, but I don't want this selection to be here anymore. I want it to disappear. Because now I would have to click this again. It's kind of an extra click happening here. I have to deselect everything there. But salut, Leonard. Yeah, so basically here with the segments, whenever a segment is created, I want the selection to disappear. Disallow adding 2 points at the same coordinate. Maybe. I'm also thinking about undo button. I think we do want to have a kind of not allowed to click too close, like what, look what I'm doing here. You're probably right. But look at this now. So okay. We add one here for stability. I think we need another because otherwise this part here will collapse. I'm not making anything like very serious now. I just want to test this tool and if it's good enough. Too many clicks. Every time I'm clicking, I kind of want the last thing that I clicked on to stay selected. Now this is really like usability stuff. And I don't have a way to remove what we did, which is annoying. Like if I make a mistake, I do want to have a kind of undo there. But this is something, and now, so this is gonna start adding physics on the object, but well, let's just do it and see what happens. Okay, some funny stuff there. But this is the main idea. It took a little bit of effort to make this tool, and I think it's worth it. But I would still like to spend a little bit of time to make this tool better, because now I lost it and I need to save it somehow. I need to save the skeleton. I also need to change position of points. And maybe what Black Maestro is saying there, that maybe not disallow adding 2 points at the same coordinates, but how about removing the point once we click on it again with the left click? Yeah, it can be improved, but there is a how to say, there is always a balance here. Do you want the tool to be filled with buttons, like click a button to start creating a segment, click a button to start add a particle? Those may seem kind of intuitive, like everything has stuff like that, like Paint, PowerPoint. You always have these things like, okay, let's make a segment. Okay, let's make another segment. Let's make a particle. Let's make another particle. This adds so many extra clicks, and yeah, I think there is some way like to select this that I don't remember anymore how to do, but there is some trick in PowerPoint to keep something selected there. But it's not intuitive at all, and I don't remember it anymore. But basically, there is a balance between adding very clear interface or adding or making an interface that is a little bit confusing until you get the hang of it, but after that you become really fast at using it when you get the hang of it. It's kind of like what we are making here is a little bit of a steeper learning curve, because maybe you click with the left click and you wanted to click with the right click, and then you're like, what happened? But after you get used to it, it's much faster to make things with what we have here than having buttons for everything and enabling, disabling stuff. So this can be made even much better, but then it's like the perfect tool for me, not the average user. So think about those, and of course you can have also a combination of both, like many ways of doing the same things and keyboard shortcuts and then whatever. Many tools have stuff like that. But for me now, this is going in the right direction. What I would like is if this one is here, maybe I want to move it up a bit. And now if I try, it just creates something new there. So dragging the points is one thing that I would really like, to drag these particles around. But if we look at the code now, it's implemented so that this has a click. It doesn't have some drag thing there. And I think we need to use the mouse down again. But on Stack Overflow, there was this person here talking about way of making both of these work. Checking if the button that you click on mouse down is 0. So then our click should work. That means left click, basically. So doing this and putting this here. And this can be, again, mouse down. I think this is going to give us the same behavior as before. Yeah, this is the same behavior as before. But now we can implement this drag as well. So mouse down shouldn't create the thing. It should start dragging, or yeah, it should start dragging the thing around. And maybe if you just click on it again, it should remove it. Yes, of course you can do that, but I want to finish today. So it's a compromise. Okay, now here, if we left click, so let's add the comment here. If we press the left mouse button. Some of these things I took from elsewhere, so I just don't remember anymore. Then let's have a attribute here for left mouse down, false by default, and this left mouse down set to true. And for mouse up, we do false. And here we don't add the particle anymore. We do it on mouse up, but only if we haven't dragged the thing, I think. So we need also a mouse move. But only if the mouse is down. We start the dragging. And on mouse up, we stop the dragging as well. So we add the particle if not dragging started. If we haven't started the dragging, then we're going to add the particle here. But if we started the dragging, we don't add it anymore. This selected particle is it's maybe something I want to do on left click. So we have a mouse down here and a mouse move. Yeah. So here this dragging started. Okay. Yeah. This selected particle has to happen on left click now. Yeah. Let's try this and see how it feels like. And here on mouse down, we do a get nearest particle. Okay. And let's just try selected particle is this nearest particle and see what we get. Oh. Okay, so now we have this, and then you move, and when you move, selected particle location is equal to oh, we need the mouse also. Wow. Get mouse pause. Like this. And like that, and then mouse up. We only add the new particle if we haven't been dragging yet. Yeah, a lot of stuff, crazy logic. Let's see what we get. So clicking, nothing happens. I broke it. Click, mouse down, mouse drag gives us errors. Okay, so mouse down. This should be the correct button. We get the mouse position. We find the nearest particle according to this location, and we set it to be the selected particle. But there are no particles in the beginning. uh, oh, this is becoming horrible. So we only want to go here if there are particles. Otherwise, well, okay. But then here, we don't actually need this. We need selected particle. So left mouse down is kind of redundant now. I will explain this when it starts working, but okay. Well, that works again. Oh. What? Yeah, I only want to select the particle if it's near to us. Now it's selecting the previous particle no matter how far it is. If distance nearest particle location to mouse location is less than this click distance threshold, then we select the particle. It's crazy. Yeah, so let's have a threshold here. I used 5 for drawing the particles before, so maybe 10 or something like that would be enough. Okay, but releasing it should stop that, and it doesn't work. We're getting there. Mouse up. If dragging is not started, we create a new particles. Else, dragging started is false. Selected particle is null, I think. Oh. Mm. Yeah, I want to delete when clicking again the same. No. I want to delete on a right click, I think. So what's the problem here? I'm clicking on this, it drags it. But if I click and release, it starts dragging it. Okay. Hmm. Yes, that's also an idea with having keys for that. Aha. Okay, Maxim. I gave you more feedback on email. Yeah, it's a good idea to use a key press as well. But something is wrong. I want to fix this, and then maybe I'm gonna put the project up for you to test as well, somewhere. Let's see. But something is still bad. Like creating particles is fine. Selecting doesn't work because selecting works only with down and then it deselects. I don't want to deselect here, but I still want something to happen to stop the dragging. I think there needs to be another and condition here for dragging started. Mhm. And it should be true here. When creating a particle, I would expect it to be the selected one. Okay, we're getting somewhere. So creating a particle. I start to laugh when I see Maxim's comment there. Creating a particle should select it, I think. Somehow, when connecting these, I want to select the last one. Okay. I dropped out and I had to reconnect somehow, and it was horrible. Yes. So I did stuff while I was off screen. Hello. I did stuff while I was off screen, and I will have to explain what has happened, but I will show all the code again once I get it to work. The problem now is, and I think it's one of the last things, we are adding the same segment multiple times if we just click between the points forever with right click. So I need to check if the segment exists before re-adding it. And I need to implement an equals function for the method for the segments. So this is going to be a arrow function here. And I will just check if return this part A equals other segment part A. And this part A equals other segment part B. Sorry, if the first particle from this current segment is equal to the other segment per first particle, and the second particle are equal, or we do the same thing but in reverse, because it's possible that we have added the segment in the other direction, and I don't want that either. So this now should work, but equals needs to be added for the particle as well. And the way particles are equal is if this location dot x is equal to other particle location dot x, and same for y. We just return true. So we can return here like that. Okay, let's see now. So creating particles, creating segments, clicking between the points doesn't add many segments anymore. So it would just re-add this again and again, and you could see it getting thicker and thicker there. So that's what I fixed now. The only thing I still want to do, so dragging works, adding new ones works really well, but removing one, we don't have a way for that. And I think I want to right click on this. So if it's selected and I right click, I want to remove it and all its segments. The final thing, and then I review the code one more time, and I also send it to you guys to try it out. So the last thing, and I'm really happy with this. So on this right click, if we are within the distance threshold, and if the selected particle is, then we remove the particle and connections and segments containing it. I wanted to use the same terminology in the comment to make it clear. This code is not fun. It's not fantastic, but this is a complex logic we have here. So it could be made much nicer. Now I'm a little bit panicking. So remove the particle. Hmm. Let's just remove the particle, the segments containing it first. So S of these segments, if S contains nearest particle, we remove this segment. But to remove it, we should know the index of that segment. So I'm going to loop here with a typical loop, starting at the end. And going towards 0, I will splice from I one element. And this here is segments of I, contains that particle. And this is a method I need to implement. So this is one thing. And the other thing is I need to remove it from the particles as well. So particles length -1, if this particles equals nearest particle, particles splice from I. So this is removing it. Okay, now finally contains method needs to be somewhere. So here we have a equals to another segment, but a contains method, there is a particle there. And if this particle A is equal to the given particle, or particle B is equal to the given particle, then this is true. And we don't need, I think, this. We don't need anything here. Okay, now let's see. Final test. Hopefully it works. Okay, right-clicking gives us error. Left-clicking like this. Aha. When we remove it, we also have to set selected particle to null. Otherwise, it still stays there as some kind of ghost particle. Okay, but why do I get error when I just right-click here? Ah, right-click, yeah, right-click here shouldn't do anything if there are no particles. I should still prevent the default functionality, so I think I can do this in the beginning already and it should work. Okay, great. So it actually works pretty much the way I intended to. I want to make a button that starts applying physics to this thing. and then I post the code for you to play with, and I explain it one more time. Let's put the button in index.html below the canvas somewhere. I don't want, I want to call this like use skeleton, and on click use skeleton like that. And this is going to be a function here, use skeleton, that does whatever I had in the console previously. And not only that, I want to also tell the skeleton editor to empty those things. Because now if you create something like this and you run this and you start again, and you run this again, oh, it actually works. But I think it's adding these particles twice into the system, most likely. So I also want skeleton editor to reset. And this skeleton editor will have here a reset method that says this particles is an empty list, an empty array, and the same for segments. And I think at the top here, we never used this objects. That's it. Now the button is here. Let's make it below. With a simple line break here. Okay, and I want to remove the selection from there too. So reset makes also selected particle null again. Okay, great. Now, let me put the code on my website somewhere, and you can play with this current version. And I'm gonna explain what I did when I dropped out. Sorry about that. I don't know what happened. I just noticed that I was loading forever. I have to connect to my website and new folder, QWOP, clone. And let's drag everything there. And it should go here. There you go. Yeah. I can't copy this link there. I have to type it here on this other computer. Or let's see if I can access the stream. There it is. So you can try it out. Let me know what you think about the usability. Basically, left click. Now I'm just left clicking. Adds particles. The last one is always selected. And you can click and hold to drag the particles around. If you right click a selected particle like this, it's going to go away. So selecting a particle and right clicking makes it go away. But selecting it and left clicking and dragging like this works only with the left click. Now, if you select something and then right click something else, it makes a link to that other thing that you have just clicked. So you can create these structures. Now here, if you want to make a link here, you need to left click and then right click like that. So it takes a little bit of getting used to, but basically you can make anything you want and you can adjust it like this. And this is, it took a while, but it's gonna save a lot of time later on. And now use the skeleton. Oh my, something bad happened. Oh boy. Yeah, I know what the problem is. It works if you don't move things too much, because otherwise, yeah, the problem is every time I'm dragging the particles around here, I should also put the old location of that particle to the new mouse location. Otherwise, the particle is created with the old location equals to the new one, but then when moving the particle somewhere else, the old location would be the previous. So then it creates that artificial moving delta in some direction. And no. So let me try to see if this fixed it. Let me create some complex stuff here and move things around, create new particles. Something like that. Let's move a little bit more. Let's remove this particle. And now use skeleton. Okay, something is still bad there. Try one more time. Okay, and I'm gonna do the same thing here, but moving stuff around. The one on the right did something that I didn't like, so let's check this again. Mouse move. Yeah, moving items causes a lot of hell. This did fix something, but now the problem is if there are segments created and then you start moving stuff, the segment original length is still the one that was in when it was created. So every time you move something, you should tell all those segments to reinitialize their length. Crazy. Let's do that. I'm gonna make an init method in the segments, and this is gonna do that. Reinitialize the length. And I will also call it here when defining it, because it needs to have the length somewhere. Okay, one more try. One object here on the left that doesn't, I won't drag anything from it. I just create the things. And another one on the right that I will mess with it. Oops. Okay. Okay, now it's good. So let me just quickly update the code on the website. And refresh the page I sent previously, maybe clear the cache or something if the JavaScript doesn't update. Try F5 to refresh, Control F5 to refresh. Sometimes the code doesn't update if it's cached by your browser. And let me try now the version on the website and really try to break something and see if it works. So let's move stuff. Let's add more points. Let's add another link here and move some more points. Let's add one more here. Let's put it outside like this. Okay. Yeah, seems good. So now test it and let me know what you think. You may need to practice a little bit to get used to it. And it's a good point I got previously from Radu that using a keyboard, A plus mouse, M plus mouse to move a point, D plus mouse, delete a point. I mean, it's possible to do that, definitely. But you would have even somehow more things to consider when teaching this to somebody else. Like you really need to start to have a list of instructions for all of the things. But it's a valid thing. It's a valid shortcut system that many applications use. Typically, it's to toggle tools first and then do the thing. If you would really do this professionally, maybe holding the keys may change the mouse cursor to indicate that something else is happening. Now I still need to write instructions for somebody how to use this thing. And it would be good to summarize them in a very, very easy way. I don't know what a good summary would be. Maybe left click, add drag points around, right click, create segments, delete selected points, something like that. Particle is kind of a strong word. It can be confusing. Segment connection, that's also something, maybe connection is better. Particles is a good word to use in the context of the physics simulation that we did. But if you think about generating this skeleton here, they are really points and lines, basically. So, yeah, this is good. We are now ready to start to create the skeleton. So skeleton editor is done, and now we are going to start to make the skeleton design next. And yeah, okay, hello. Gaurav, I used to have a student named the same. Let's have a quick look at the code here, because I dropped out in the middle of this. So on mouse down, we only do stuff if the left click. So basically on left click is what you read here. We don't do anything on mouse down when the button is down if there are no particles in the system. But if there are particles, we get the location of the mouse, we find the nearest particle. And if we are pressing just on it, next to it, if we are close to it, then we start dragging and select that particle. On mouse move, if the particle is selected and we are dragging, then we get the new mouse location because we're moving the mouse. And we are setting the particle location and its old location to this so that we don't have that delta thing. Now, this logic here is confusing because somebody would need to know that a particle has a location and an old location. So maybe a better code here would be set location to the mouse location. And now we need to write a setter for this particle. So here we would have set location, new location, and this lock is new lock, and this old lock is new lock. We could also call here in the constructor set location, but we still have that delta for testing. I don't think we will need that anymore. I don't think we will need that anymore. So let's just this set location to the location like so. And now this is easier here because we set its location to the mouse location. We don't need to remember that other thing. But the segments need to be updated as well. So reinitialize segments, because if we drag stuff around, the segments that are initialized with the length that they should have between the two particles that are connected, if particles are moving around, we want that length to change. This is the editing mode where physics don't apply. It's just creating the segment, and we want them to have the proper length. So any drag needs to take those into account. Then on mouse up here, if we release the left button and we didn't drag anything, we just create a new particle. We add it to the particles and we also select it. If we are dragging something, so here in else, we stop dragging the thing. It still remains selected. Context menu is basically right click, but we prevent default behavior. So that means that we don't get the menu appearing on the right click. We don't do anything if there are no particles. So right click, it's just for deleting particles and making connections between particles. So it makes no sense to do something here. But after that, if we have particles, we get the mouse location, we get the nearest particle. If we have clicked on it, so the distance is close, I'm cheating here a little bit because there's no hit test, hit detection on Canvas. So I'm using the distance and I assume the particles are circles. And I actually have a little bit bigger radius, so you don't have to be very specific there. But close enough, then if we are right-clicking on the selected particle, we remove it. We remove first the segments that contain that particle, and we remove the particle itself, like so. We also deselect the particle that we removed. Else, if we are not if the thing that we right click on is not the nearest part, is not the selected particle, we make the segment that connects to that. So connecting the nearest particle to the selected particle. And here we only add this segment if it's not there already. So it's possible that you add a segment, like for example, now you have added the segment, but if I right click now here, it would have added another segment again. And another segment again and again, the same segment multiple times. So this is what I did off screen, a way to find if there is that new segment that we want to add already in the segments list. And if it is not, then we add it. It's a new segment, really a new segment. And I also select the particle that we just clicked on because somehow my brain says that when I make a connection, I want to make connections from the endpoint. More likely. I mean, it's the way I do things. I don't know if other people do, but if I don't want to make connections from that endpoint, I can just deselect it. If I don't have this thing here and I normally want it to be selected, that means an extra click for me. So I'm thinking a lot of this behavior stuff. And that's it in short. Other things include stuff I did off screen is this equals function for particles. Two particles are equal, like this particle here, it's equal to another particle if the location x is equal and the location y is equal. Two segments are equal if particle A from this segment is equal to particle A of the other segment. Particle B of this segment is equal to particle B of the other segment. Or in this case, I don't want even the reverse to be true. So particle A from this one is equal to particle B of the other one, and particle B of the other one of this one is equal to particle A of the other one. So they are flipped. And last, I added this contains function here. So if a segment contains a given particle, it will return true. Otherwise, it's not. So if particle A is equal to the thing we are testing for, then it's true, or this is true. If none of them, then the segment doesn't contain that particle. So relatively small, simple logic divided into these chunks. But here, this is kind of a mess. I would probably divide this into many functions like handle left click mouse down or something, and then have this all code from here would be just one line. And for mouse move, I would extract this part, and this I would extract. So all of these are callback functions that we written here in line. The reason I don't want to do that is because we're using this here and might cause some issues if I give names to these and extract them as their own functions. Then it may lose what this is about. It's If there are methods, it should work. But anyway, I'm happy with this. I don't want to overthink it, and the logic seems to work. Okay. Um, yeah. So let's go back here, and now you can see these things are just falling because basically this is not used anymore, that delta. So all particles by default are just falling like that. That's just what happens to them. It's okay. And what we will need to do is a way to, after we create the skeleton, to save it so that if I refresh the page, I don't have to recreate the skeleton. That's going to be very important. Yeah, that's going to be important. So skeleton design comes now, and also saving the skeleton. It's still kind of like skeleton editor, skeleton design, but it's just fine. So let's start designing something and implementing a way to store it. I'm gonna use local storage to store the skeleton in memory. Probably. Yeah. Hmm. And let's look how a moose walks. Maybe we find a good GIF or GIF online. None of these look like they would walk nicely. I want to get some kind of inspiration for how moose walks. Oh wow, this is really good. But I wonder if this is really how they walk. Like, do they really alternate the feet like this? I mean, this is a 3D animation, but if it's real, then this is going to be really useful to take as a kind of inspiration there. Okay, this is some kind of camera that captures very few frames per second. Okay. What is that? Uh, there are two of them, one next to the other. Wow. This is so weird. Hmm. No, I don't use. I mean, those don't make animations. But look at them. They do walk like that 3D animation from previously. It's so crazy. I'm gonna use that animation as okay, I don't know what that is. But I'm gonna use that animation as a kind of reference thing. Where did it go? This one. And look at this. It's actually so that if you just look at the front legs, it's like a human. It's like a human would walk. Like only focus on the front legs. It's basically just a human walking. You could imagine a body coming from that point. And same happens with the last one. The ones in the back are a bit more, I don't know, like the human is wearing high heels or something. It's a little bit different structure. And the leg actually starts off here and in the back here. Like, seems to be like 3 segments to the leg. 1, 2, 3. And also something at the bottom there, but it's confusing. I think I just keep 1, 2, 3 segments for the leg. Yeah, it's kind of like the human there. It's going good, but I dropped out at some point and I had to review some of the code. Okay, so I will start with with these front legs, and then the rear legs, and then I do the body. And the head, I don't know if I do the head. Let's see. Because eventually I'm gonna skin that skeleton, so it's not gonna be just lines. And I'm going to make, so what I'm gonna do now is I'm going to create a skeleton with this skeleton editor tool that we built in the last few hours. So there is now this tool here that we can use to generate different structures. And I'm looking for inspiration online to look how a moose walks. But the skeleton, you design it, and then when you use it, physics start to apply to it. So this editor here for making the skeleton should save me a lot of efforts. Now, yeah, it's great, isn't it? Okay, so I was looking at these animations and real footage of moose walking, and I was amazed that if you just focus on the rear legs or the front legs, they look like a human walking almost. There is kind of like an extra joint there, but and I don't know if I really want to complicate everything with an extra joint. I mean, this part from the top here kind of looks like one single joint. I'm now worried a little bit, how many keys do we need? Because in this QWOP, we were controlling the thighs and the calves. But now this thing seems to have more muscles than we have. And we may need more keys, and I don't want that. I still want to somehow control everything with QWOP. Yeah, okay. I'm really happy with that 3D one. We did see before some other ones where more realistic ones like that. But this 3D one is like, I think, really well recreating it. This one as well. Yeah. So 1, 2, 3. I will use 3 segments, and here in the back, it's complicated. Let's use 3 segments in the front and 3 segments in the back, like same as here. So we may have to try multiple times, but that's why we made this editor, so that now it should be easier to get it to work. And yeah, let's see. Oh, what error is this now? I'm not sure what I did, but some error came. Dragging stopped working after I did something now. Ah, set location. Okay, again. So the front leg. I'm trying to draw the front leg here. Something like this, I think it is. Let's see. So this part here, and that part there, almost equal in length, all of them. Something like that. Yeah, it's common for many coders to have code like that. Okay, so this is the front leg, and the back one is a little bit lower. This part at the bottom is longer, and these are shorter. This is similar, this is much shorter, and the bottom one is longer. So let's just try. Something like this. So now this is kind of like making a connecting the dots game. Okay. Okay, and let's add structure here. Well, in Finland, moose is everywhere. I want to have maybe more characters, not just moose. Somehow was thinking in the beginning that I try with the moose so that it's something different, and maybe others haven't tried with the moose. But was talking with my wife in the morning that she was saying that giraffe might be very funny with the long neck and the long legs. So maybe we try both of them. Yeah, it will be later on YouTube. I just hope that I don't drop out again. Uh, it happened. Yeah. Okay. Mouse. No, moose. Moose it is. At least for now. But we can try other things because that's why I made this level editor, this skeleton editor tool, so that it's easier to make. Okay, let's connect these. So, and I'm adding these. Hmm. I wonder if these kind of stability joints for the diagonal are good like this, or should they be some other way? But let's just do something. Okay. So now we have these, and we need the rest of the body. I think I'm going to make the body as a kind of it needs to be connected to these things somehow. I wonder if it makes sense to just make a something like this, a big thing, and make some connections here and there. Okay, so let's make this thing. And I really don't know where is the best way to connect this, but the leg has to be connected like biologically somehow. So maybe this thing here is something. Maybe this thing here is also something. And now this middle section here needs some kind of stability, structure to it. So I need to connect this one to this one maybe. Usually triangles are a good thing to use. Okay, now I drew this and I'm kind of happy with it. I don't know if it's gonna really work or not. Um, yeah, moose, goose. What's the plural for moose? I know the plural for goose is geese, but the plural for moose is not meese. Maybe it is meese. Headless moose, yes. Well, I guess I could give it a head. I don't know if I'm happy with this, but it's something. And we will skin these eventually and it will look nicer. But now let me save this. I spent a lot of effort into this and I need a way to save this information somehow. So I don't lose this when refreshing the page, because when I start the simulation here, um, horns are a stylistic thing. It doesn't need those now. Yeah, turtle. Basically, I don't want to lose this skeleton, all these coordinates that I'm using here. So I'm going to go here and save them somehow. I think I will do it in local storage. So I would serialize all the particles and all the segments inside of our skeleton editor. So these particles and segments here. What happens if we type here skeleton editor in the console? What happens if we JSON stringify it? Okay, it has the canvas, it has the context, it has particles, what I need. And then skeletons. And then it also has weird stuff like selected particle, dragging started, and so on. Old locate. Oh no, that's fine, I guess. This is difficult because you see here, particles have location, alt location, whatever. I just need one of them because they're always equal here. They haven't moved yet. But the problem is the segments are just defining particle A as location, alt location, but these don't match to the original particles. Bummer. So I can't just paste this in local storage and reuse it because the particles need to be, the segments need to be specific connections between the particles and initialized with the lengths based on that. And now it's basically copying the locations of the particles, but not identifying them as such. Particles is relatively easy. So I could do skeleton editor particles. Let's map each particle to just the P location and JSON stringify this result. And this is telling me particle locations here. So this is particle locations. And this is good. But I need to know from the segments, so which of these should be connected, like the index of this location needs to be known somehow. So this is more complicated, significantly more difficult. And So if we do skeleton editor segments, I don't get that. I just get this kind of part A and part B here, some length that I could recalculate with the real initializing it. But here particle is not the index there, and I need it to be the index. So I think I need to loop through the particles and make a new way of indexing here. So let's do segments map. Each segment is going to be, instead of the part A gives me the particle from there, but I need to know its index in the particles. So complicated. Skeleton editor particles. Uh, I want to know the index where you find this particle A. But it's an object, so yeah, index of, but it's an object and it doesn't. Yeah, I can format the code with something if you want. I mean, I'm using this prettier all the time, but here I don't have it. Mhm. I mean, index of, it's not going to work if I put S part A here, I think, because it won't find that object there. Or it works. Oh, it works because it's the same reference, maybe. Yeah, you're right. You're right. It does seem to work. Good point. I forgot that the locations are actually coming from the particles and the particles are passed as reference. Okay, so this works, but I don't want just that. I want S to be mapped as part A index, and that would be equal to what we did here. And the second will be part B index, and it's the same thing with particle B. Why is this an error here? Oh, this needs a return, doesn't it? And another one, because it's not just one value, it's this object. What am I doing wrong here? I want to create a new object that has this first attribute and this second attribute. That would give me the index inside of the segments list, but I don't want that. I want to know the particles index, like this, basically. I mean, here I want to return an object, like the same way that we are returning objects in math here. So I'm returning X and Y attributes. So here I want to return part A index, part B index. And for some reason, this is not... Really? Okay, that's the problem. Okay, I'm getting some numbers here. I hope they are correct. Thank you all for figuring out this with me. Yeah, indentation is important. I just hate this. Yeah, I think I'm back. I hope. I could see your chat this time, and it helped figure out that it's bad. But basically, I have here now the skeleton serialized as a JSON string, and it's in the local storage. So what I would need to do now is so this save function should do also those things. Here it's already called connections and particle locations. And saving it in this skeleton object. And loading should also be implemented, load. And this will be, well, it will reset the skeleton editor. So this reset, and then get the item. So get item and then parse it. like that. And let's parse it like that. And this should be skeleton info, like the information we need to generate the skeleton. And from it, we actually get these connections and particle locations. So we could do object destructuring here and say directly connections and particle locations. And based on these, we can generate the particles. So for const p of particle locations, we can generate the particles. So new particle of, let's call this p-loc. I've been using p as short for particle. So yeah, and now going through the connections, we say this segments push new segment, and this is something I forgot here, particles push new particle. Like that, and here we add a new segment of this particles of c dot part A index, part B index. Okay, so this is it. What is happening in the chat? Red usually means bad stuff, but it looks like I'm getting some money there. Thanks. You don't really have to, but thanks if you feel like you want to do it. And thanks to all of you, Shubham, and people I can't really pronounce. Ersagun and Black Maestro is easy. Okay. And yeah, I'm still going. I'm becoming really, really rich. Yeah. So, I'm a little worried, will this work or not? But let's see. So let's actually use the skeleton and see how this collapses. I don't think this is gonna work well. Okay. Still a little work to do. Mm-hmm. I don't know what it is. Yeah, it really is a turtle. But let's see, can we get back the skeleton? So refresh, and now it's gone. I really hope what we did is good, because even though I have a feeling we have to redesign the thing. So skeleton editor load. Oh my. It works. The loading works. The loading works. Yes. Great. Fantastic. Ah. Yeah. Thanks a lot for watching. I have fun making the stuff. Yeah, the skeleton doesn't work. Let's see what the problems are. This load, I think, let's just call it by default when we load the page here. So skeleton editor load. And now every time I refresh, it's coming there by default. What's wrong with the skeleton is I don't know. But I think what I want to do is slow this animation down. So let's open here animate and put a breakpoint. Here. This doesn't work. I want a breakpoint here, but I want after I press the use skeleton. Maybe I just do it very quickly. Too slow. Ah, okay. I see. I could see it somehow. Use skeleton. Let's press this automatically. So now it's coming like that. And now I can put the breakpoint here. Maybe at the end of this after it's doing the drawing. And now this bending here is not really natural. This bending here is also, yeah, our segments are not that rigid apparently. And also at some point, these are just two connections to the body there, so the leg flips on the other side. So we need to update this a little bit. Yeah, let's not use the skeleton and remove the breakpoint. And here, I'm not sure, maybe connecting these as well. Let's try and see what happens. It's better. These things here don't go up anymore. So let's re-add these. I didn't save before. And now skeleton editor save. Let's try again. Yeah, so the save also works. And now, I don't know, let's just try connecting also these other connections, even though in my experience it doesn't go well. When you have too many segments here, it's a bit bad. Let's try. It's more rigid, but stuff starts to happen there. bridge making simulator. Yeah, something like that. So one thing that we are not considering at the moment is that when one segment gets fixed, another segment gets broken a little bit. And this is just how this thing works here in the physics. So we update the particles, we update the segments, and then one segment, maybe it's too long. It's going to be made perfect length, but then the segment connected to it maybe was fixed previously, but now it broke. So when you have complex connections like this, the only way you really fix this is by looping several times and making these more rigid. So we could have something like that. And we loop everything here apart from the drawing. The drawing only happens once. And this rigidity is, let's have it as a static variable. Let's say we loop 10 times and see what happens now. Okay, I didn't save those X connections here, but let's see what happens. Aha, okay. No, I don't want that. Particles updating I want before, but fixing the segments is what I want repeated multiple times. That's the problem. One segment breaking the other, and if you do it repeatedly, it's gonna eventually disappear, the effect of one having an effect on the other, because they go towards their preferred length closer and closer. It converges to a kind of a stable state. So let's try again. And now it works okay because of this added rigidity that we added there. So it can stand. And some things still need to be made differently because this is just one leg in the front and one leg in the back, and we need another pair of these. No, it needs to be this model. No. It looks like a statue. Pung. Okay, maybe it was a good idea to try, but I don't want it to be that rigid. I like a little bit of this jiggly effect to it. At least when playing this original QWOP, it's kind of like that, the feeling there. Okay, so you tried a similar stream on Twitch. Um, yeah, I mean, in the beginning when I first made some live streams, I had moments when nobody was watching and I was talking to myself, and sometimes it was like hours where nobody was watching. Um, I know the feeling. It's something. Yeah, body heavier than legs. There's no weight here really. Each particle is the same in weight. Yeah, second row of legs. That's what we need to do. Jelly simulator. Yeah. Um, no, no simpler model needs to be complex. So So let's somehow, I would really like to have a kind of feature in this skeleton editor that lets me copy paste these legs below. Basically, they should be exactly behind each other. Let's have a look at the walking again. I'm thinking how to make it walk. So before adding the second pair of legs, let's try it with just two legs, one in front and one in the back. Yeah, it's trying to keep the thing upright. Well, if that's the end goal, I think that we did it. No, the end goal is to make it walk, controlling it with the keyboard. So what I want to do now is, even though it doesn't have four legs, just two, try somehow to move the legs with the keyboard, if that makes sense. And I'm thinking how to do that. Hmm. Yes, I will do that. I will change some of the segment's lengths. I'm thinking about making this segment shorter, this one here, and making it shorter, it's going to force this one to be higher here, making this one here longer. This one longer and this one shorter is gonna move this whole leg forward. Middle segments, I think, is going to have, I mean, if you're talking about diagonals, I'm not sure what the middle segments, what you mean by middle segments. But if these would get longer, uh, they just deform the whole thing. Like it will, if this gets longer, this collapses into a line, essentially. And the leg becomes longer somehow, and some weird stuff would happen, I think. I think. You may be right. It could be a fun thing to experiment with. Yeah, okay, diagonals. Hmm. I really don't know. Maybe it works. We could try and see what happens. But I would need a way to identify this diagonal here, and I don't have at the moment a good way to do that. Unless we did have the code for when adding the segment again. If we find the segment, else let's log it. So now if I'm going to select this diagonal here, like so, with left click and now right click to try to add this diagonal again, I'm gonna get a link to it here. So I know which segment I want to modify to increase its length. But I would like to know which one it is in the list of segments. So not enough. Index of, again, let's see. I'm not logging it. I moved it a little bit. Let's refresh. -1. Okay, it doesn't work. It doesn't work because it could have been generated in reverse. No, it just doesn't work with index of. Because it's a new segment, right? It's a new segment. I could do this. Like that, and now log this one, which should work. The one that is according to the match. Yes, okay, so 25. So now if I type here segment editor, skeleton editor, segments of 25, I have it. Okay. Let's take it here and let's use the skeleton. And now if I'm going to say seg length, it's 104. It's 104. Yes, very good point. Ninja Coder Tech. I did that. I found it, the one with the same properties. But if I make the length bigger, then the code that is handling the physics is going to try to make it work with the bigger segment. So it's going to increase this one. If I increase the length, this whole quadrilateral here, it's going to get more squishy, more stretchy this way. And that may also make this move forward. Let's try to put a length of 110, like 110 here. Nope, it did something. Let's try again. I don't have it anymore, so the same thing. And oh, I know it's the same index always, so yeah. And let's try put 100 instead of 105. So now it's gonna squish it the other way around. Oh, I didn't press use skeleton. It did it, but yeah. So again, get that, use skeleton, and now a shorter diagonal here. It's gonna be, it did something. Let's try 90. Yeah, it's moving. Yeah. Um, okay, so we know 25 is one of them. Let's try to get also this one, 24. So let's give them a name. Maybe 25 is going to be uh, up, right, or no, front, top, like the front leg and the top part of the front leg. So it's that, and front, mid. And we are now just talking about diagonals here. And let's see what happens if we do now this front top. Let's use skeleton, and front top length is 90. Okay. And front mid length is, let's try to make this one, it's very hard for me to see how it goes, but it should be bigger, I think. Longer. Let's try. What is its actual length? It's 63. So let's try 70. No. Again, shorter. It's so hard for me to... Okay. Interesting. Let's do everything in once. So we have front top. Like that, and front top length 90. Front mid length is 55. Let's put 50 even. And now use skeleton first. And now damn. Skeleton editor is missing now. It's no longer from there. It's from the physics. Should preserve the same. Oh no, it doesn't preserve because this one, it's gonna mess up the indexing. I think when we use the skeleton, we need to destroy the physics particles. Let's just use skeleton editor particles instead. Now I'm adding them, but we stopped needing these these two particles for a very long time now. So I just replaced them like so. And this should preserve the index now. So So now when I press use skeleton, those go away. And now it did move in front, but is it really? It does kind of resemble that. Let's try again. Let's try 85 here. Um, sure. And then maybe this one also. 23. I didn't know how large the front bottom is. 86. Okay. Okay, that's something. Yeah. I don't try 0. But we have some values here for the front leg when it's in the front part. I think this could go even more behind. Um, let's copy this code somewhere for reference. And let's try this one with 65. Maybe 80 is a good value. So 80 to 50. And this should also change a little bit. Not like that. Oh boy. No. This oh, I put 7 instead of 70. Let's try 70 and 90 for those bottom ones. So this would be for forward, and this with 70 and 90 would be for when it's back. And this should stay the same, I think. So let's just 104, but we don't need to. Guess that's good. So I guess this is good. Okay. So now we have the value for front, top, front, mid, and front, bottom, but these are the values for when it's moving forward the leg, and this is when it's moving backwards the leg. Probably interpolation or just increase them. I'm not sure. Let's see. I think I make it so that when we press a specific key, the leg. Yeah, it's 4 legs. No, it's complicated. So one key could move the leg forward, and another key. This is so complicated. Everything is offset here. Like, you don't have 2 legs moving at the same time. You really need to move one leg forward, one leg backward. You need 2 keys for one leg, and you have 4 legs. So it's like 8 keys, and I don't want to have 8 keys. It's horrible. But something like that, like as long as you keep one key pressed, it's gonna go. Yes. Well, I don't know. I would like to keep the original idea of QWOP and use the QWOP keys. But that would mean, like, if I press one key, moves the leg forward. If I press another key, moves the same leg backwards. Let's start with that and then think what we do. And I don't remember anymore how to do key listeners. Um, Maybe I use this chat GPT. Yeah, something like that. Mm, I mean, I could find easily stuff like this online or even in my old tutorials, but I asked it to be quite specific here with the keys, and I think I save a lot of time just doing this. It's pretty much what I would do anyway. So I don't need this anymore, and I'm going to go here to controls, JS. Let's just paste everything here and include controls JS. And in controls JS, I don't bother making this a class or anything, since this is going to be, I guess it can be on the window, that doesn't matter, but let's see if this works. So here, and now I'm pressing Q pressed, Q released, W pressed, W released. And if I'm holding W, it stays pressed until released. Yeah, everything seems to work. Yeah, good idea. Do the front legs alternate? Kind of, like when this front leg moves forward, the other leg moves backward. If you just look in the front two legs here, um, good idea. It's a very good idea. Yeah, probably you learned, and now you know where I learned them from. No, it's very basic stuff, but I just didn't bother now typing everything, and um, yeah, and this is still not good. There are some issues with this implementation, because if I do something when Q is pressed here, you can see I'm now going to start pressing Q here. I will start press Q and see what happens in the console. There is a moment when you press Q that it says there Q is pressed, and then it waits a fraction of a second, and then it starts to repeat like really, really fast. And that's just because when you type things on the keyboard, you don't want to accidentally type 10 letters instead of one because you kept it too long on that letter accidentally. So there is a kind of a threshold for in Windows or whatever operating system you use, so that it waits a little bit so that the person has time to release their hand. But this is a problem because our elk is going to move so that it moves a little bit and then it waits and then it continues to move really quickly. So we need to implement this in a way that we can use in a smoother way. So I will implement this as a class. And I will add these event listeners probably in the constructor, just like that. Or not in the constructor because it's becoming really messy. So I add these as a method here. Like so. And here in the constructor, I say Q down. Let's give them some more intuitive names. Let's say that O and P is going to be the front legs. So O and P, front legs. Spreading them apart or putting them together, something like that. So maybe this is a good idea. Let me know what you think. and Q and W rear legs, back legs. Same kind of logic. And now we say here front spread is 0. Let's say this is like the default. And oh no, I still need something to measure if Q is down or not. Yeah, this Q down is false. Q down, W down, O down, and P down. These other things with the spread will be useful later, maybe. But now Q is pressed. I just want Q down true. And W is pressed. W down is true. O down is true. And P down is true. In the end, this didn't save me much time, really. But I could have asked it to do more stuff. I just didn't. So let's just copy this. And we put these false everywhere. Let's add these listeners. And let's see what we get now. I'm not initializing these controls anyway. Yeah, now it works. Yeah, it can end in disaster. That is true. It could be. It will complicate stuff a lot if I make the animation more realistic, but I'm gonna have to stop. I would really need the skeleton class. I mean, I need to hold these values of what's the maximum and minimum for each of these segment values. And I can't find anything here that is good to hold them. So let's just make a simple structure for now and say like that. No. this needs to go in the skeleton class. Let's make a skeleton class. And let's give it the particles and the segments also. Like so. And we need those values. 0, something like that, for how spread the legs are, basically. And I think the controls should be accessible here as well. But let's copy these things there. And these have a name now. Like that. And front spread, back spread. Between 0 and 1. But I want to know minimum length and maximum length of these. So they should be defined somewhere. Okay. Maybe this is a good structure. Have the minimum. Let's see. And the maximum. I don't need these anymore. And now what I want to do is I want to change this according to this value. So this will be between 0 and 100%. So between 0 and 1. I guess I lied about the machine learning course. Oops. Well, Node.js is just a way of running JavaScript on the backend, without an interface. And since many of the things there didn't require an interface, writing them in the browser would be like, why are you doing this? And you would have to use the console in the browser to debug, and it's like horrible. But we are not really using stuff from Node.js that aren't already available in the browser. We did use a Canvas library in Node.js, and that had to be installed. But it's already available in the browser. It's kind of installed for you. So really what I mean with no libraries is we don't use things that do the machine learning for you, and also implementing the application. Like, I mean, if you think about drawing lines as something that you would have wanted me to implement there, that course would be 3 times longer. And who watches it when I say, okay, now we draw a line from A to B. Let's implement the function. We have to find out all the pixels between these locations and light them up so that they look like a line. Now let's draw also some letters here. To draw A, we need to look at the Bezier curves defining how A looks like and implement the function to draw the curve. Nobody would watch a course like that, even though I guess that would mean no libraries. Like talk to the pixels directly and tell them to light up. So sure, I'm using libraries, but I think most people would agree I'm not. Uh, Up to you to decide. Just stop watching if you don't like it. True, but he does make a point, and I even mention it in the course that I am, whoops, using libraries there. So if you want to be really nitpicky here, you could. Right. So depending on this value between 0 and 1, I want to get values between 85, 104, 80, 50, and so on. So I need this to update according to the controls. Kind of makes sense to me to give the controls to this skeleton instead. Kind of like what we did in the self-driving car course. So the controls are defined here. And now we give this an update method. And if the controls say Q is down, O is down for the front legs. So if this control dot O down, then increase the front spread by a value. Something like that. I'm not sure if this is the speed, basically. Like so. And after we do that, we have to set the length of the front top, front mid, and front bottom according to these min-max ranges. So this front top length is going to be in between minimum of front top and maximum front top according to this front spread value. So this is where we can use linear interpolation. So between the minimum of this front top, maximum of front top, and according to this front spread here. Yeah, so this linear interpolation, I mentioned also in the beginning the videos where I teach some of those things, but it's quite easy stuff. So between A and B, you get the value depending on a percent value t. Now we have to be careful because if t goes outside, it does extrapolation, and that will be something, some surprises happening there. And at the moment, it could increase. And let's actually move this down here and have controls for the P down, because P is gonna make them together. So the spread will decrease. So P down, then the spread is gonna get minus by a value, like so. And yeah, I think this should have been front top dot max. It would make more sense, but here I'm keeping the segment there, front top segment, and that's the diagonal. So it's hard to come up with good variable names here, and I don't like it very much, but it's okay. Yeah, so can we try it? This skeleton needs to know where it gets the particles and segments from. So use skeleton here. Let's have a skeleton equal to null. And in use skeleton, we say skeleton is new skeleton of physics particles, physics segments. And skeleton update needs to happen on each frame after or before the physics update. Yeah. We also have to include skeleton. And let's see how many errors I have. At least one. Okay. And now pressing P. Oh. P and O. I'm pressing P and O now. Wow. P and O and P and wow. It's crazy. So P does this and O does this. Yeah, something is weird here. um, hmm. I think this speed increase here is probably too much, at least when testing now. Oops, I clicked on something. Yeah, something is not looking good at all here. I think it shouldn't be the diagonal here. I think it should be actually this segment here at the top that moves. Let's put a bigger speed still. Okay, I click on the screen a lot and then this level editor starts. I don't like it very much. But let's see. So what is that other segment? This. Ah, it's doing now use skeleton automatically. Mm-hmm. And now skeleton here can be null. And this update here doesn't work. Okay, so this one instead, 16. Okay, I think back again. So one thing here is this should really be 0.5 in the middle between these ranges when we initialize the skeleton there. Let's try to add also that 16. So front, top, right, 16. Something like that. Wait a second. Undo, 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 undo. I'm only moving one of them. I'm only moving the front top. Mm-hmm. I don't like this. Yeah, let's just do it for now, but I think I'm gonna rewrite this as an array structure and just loop through them and do these things for all of them somehow. So front, top, same for front, mid. And front, bottom. Okay, now when we test, okay. Wow, okay, this is not bad. This is not bad. It's not bad. No. Oh, okay. Oh boy. Mm-hmm. Yeah. Let me put the current code up in case you want to try it out. Oh, but you don't have the skeleton. Damn. You need the skeleton. Let's give you the skeleton. So the skeleton editor has here a load functionality, and this one gets it from local storage. Okay, and this is going to be just an ugly hard-coded string here. And now if I update this code on my website here and I wait for it to load, you should get the same things. And pressing P and O works after you press this use skeleton there. So P and O, P and O move that front leg back and forward. Yeah. Yeah. So if you test the link, refresh, maybe clear cache if it doesn't work, and then use skeleton, and P and O move that front leg only, but of course the whole body is kind of shaky. And I have to work on the limits there because now I think the values are going too much. Da, merge. Mm. Mm. Sau nu. P for a long time. Wow. You know what? I'm not even gonna try to explain what's going on here. But look at it go. It's, it sure is fast. There's one thing that is not good at the moment. There's no friction with the ground. I mean, even if the movement is good, it's like it's walking on ice. Flying knees. Yeah. So it needs friction with the ground. Not sure what the best way to implement it is. I guess we could say that if these particles here are touching the floor, don't move them horizontally. I mean, that's what would happen in the real world. The moose doesn't slide around. The moose. Yeah. Let's try something like that. So we need to figure out which are those particles. I'm going to close this tab because I don't want to work in the wrong place by mistake. And I really need to know which are these particles. So maybe I can do, or maybe we do that for all particles. Yeah. So in the physics update, it's kind of a dirty trick, but I think it should work. So here we keep above the floor greater or equal to, then we force that to be the case. But also, let's see what happens like this. It's different, I can tell you that. It's not lifting its leg up. I think it should lift its leg up. But they are stuck now, the feet on the ground. So it did do what I wanted to. Let's try to play also with the rigidity a little bit. I'm going in reverse. Well, it's going somewhere. Yeah. I could do something here so that it's more towards the old location. So maybe linearly interpolate between the current x and the old location, but maybe towards the old location. So 0.8, for example. And now it's not gonna be like stuck into glue. It's gonna be a little bit more moving, but wow. Okay, maybe less. Tough. Okay. Okay. I want to have for the back leg as well. And let's use the same strategy. So I really think that this is just not enough. Somehow the movement should be more up and to the right. Like it should really lift this leg up. Hmm. I would like a kind of a simple way to do it, not overly complicate things. Well, this thing has two legs, so at the moment it is the spitting image. Mm. 'Let's do the same for the rear one. So this is 4, this is 8, this is 12. 4, 8, 12. Back, top. 4, 8, 12. 4, 8, 12. And now 64 would be midsection. 64, 87, 85. So these are back, top, mid, and bottom. And this is mid value, so we would need a minimum value and a maximum value again. Let's just guess. 64 minimum would be 55, 80, and 75. And here 70, 95, and 92. Something like that. And those things need this as well. I will refactor this soon, but actually I want to change here front with back. Like that, and this back spread comes from here. And not with O and P, but with Q and W. Okay, now let's see what we have. Nah, not very good. So I tried just doing the back legs movement now. Mm. That's something. Yeah, I like coding like this, but it's rare I find the time nowadays. Windows I use now. But I use both all the time. Yeah. So, I don't like this. I think we can do better than using the diagonals. I really think that if I want to move forward, this part here has to be longer. And now it's 59, so basically 60. 55, 70. That should be okay. So this should be longer. Let's just see the effect now. It was moving good. This is growing when we press Q. And this is definitely going forward like that. This thing could also go in reverse, but I don't think it's needed. Okay. But now I want to actually remove these other things. Let's not modify the back mid and the back bottom at all, and only focus on this one segment here. So it's definitely going forward. I can almost even advance with just that. Let's do the same strategy. Yeah. And the one in the front. Let's also disable the front mid and front bottom because it's just too much to figure out. Now P and O. So this diagonal does move it. Let's have the walking thing here. Okay, for this to move up, I think we need this segment here to get shorter. 17. So it's 64 by default. This front mid 64 by default let's make it between 55 and 75. And this is 17 now. So front mid 17. Something is happening. This, I think, also needs to get smaller. This one. 16. Let's not use the diagonal here. So this becomes 16. And the default value for 16 is 76. So let's make it between, I don't know, 68 and 82. No. No, this doesn't go good. Yeah, it's funny how I get it to go the other way around. Yeah, good luck. No, I think it was better with the diagonal there. It's hard to figure out which ones to put. Hey, it can't move. I mean, it has just one leg in the front, and if it tries to lift it up like this, it just falls because there's not the other leg supporting it. We really need to get the other leg in front. I mean, here when it's lifting this leg up, the other leg is holding the weight, and now there's nothing to hold that weight. So yeah, we need more particles and more things. Now I could try copying these particles. Or I could make new ones, but it's hard to do on top. Let's see. The first particle. I guess I can't make it like that because it refreshes too quickly, but let's make when clicking on the things in the skeleton editor, if I click on a selected particle, to select the particle, it should somehow I want to see the particle here. So this one. Mhm. Okay, I'm getting this. Ah, I want, when I click on this, to add this particle to make a clone of itself and all the connections to the existing particles. And then I'm going to click this, make a clone of those connections and everything, and this and this and this and this and this and this. And when I'm done, I want to have a clone of everything that I will just add to the structure. So every time I click on this here, I don't want just to get P. I want to get its location, make a new particle with this. Let's say temp particles and temp segments. And here, first we get the segments with this particle. If S contains P, I want a new segment with kind of a copy like this. One of them remains the other particle, but this one would be a copy of this P. So copy P is a new particle of P lock, like this. And now I want copy S is a new segment with copy P and whatever is not P from here. So S get other particle than P. I know it sounds kind of complex, but we need get other particle than P. So like that. And I will return if particle A equals particle, then this particle B, part B. Otherwise, this part A. So basically returning the other one than the given one here. Okay, and back to our editor here. That's how we get copy S. So we have copy B, new segments from that to the other particle, copy S, temp particles push copy P, and temp segments push copy S. And these may cause problems because we may add the same segment twice. Like here, if we click on this, it's going to add all these other segments. And then when we click on this, it's going to add this one again. So we need to figure out how I did this before. I actually forgot. This thing. So we only add this to the segments if this temp segments, we find an S equal to copy S. If we don't find it, then we add it to the segments. Okay. So this functionality now, it's not really a functionality for the editor. Easy to explain one, but it's one that I need right now. It could have a nice interface and more explanations, but I'm gonna go with this. And now, when we click here, I expect to have in the temp particles 1 and in the temp segments 1, 2, 3, 4, 5. So skeleton editor, temp particles, it's 1. And in the temp segments, 5. Okay. Now, when I'm clicking this one also, it should be now 2 temp particles, both of these, and segments is 5, 6, 7, 8. Let's try again. 2, 9. Oh, no, it doesn't work. 1, 2. So when we click this is 1, 2, 3, 4, 5. And now this one Okay, there are some more that I don't see very well. 1, 2, 3, 4. And there's this one, 5. 5 plus 5, it's 10. But this one is counted twice, so it's 9. I think this is correct. So now I'm going to click this one and this one. I moved it. Let's restart. Click, 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 and click. And now if I check 8 particles, 18 segments. So I want to add these to our skeleton. So skeleton editor particles is skeleton editor particles concat skeleton editor temp particles. Okay, let's see. I think it worked. It's hard to see, but I see them double somehow, like drawn on top of each other. And the same thing I want to do with the segments. And now hopefully those segments are also copied. Okay. And now let's save this new skeleton. So I think use skeleton was also saving it, wasn't it? No, we don't have a save button. I think we just have this, so in the console. Save. Okay, and now if I refresh, this is clearly to me that there are two things drawn here on top of each other. And when you refresh, it still stays like that, so I think it works. And use skeleton. Now you can even see that there are kind of not exactly in the same location there. It has to do with the order of how the segments are fixing each other. So now if I move the front leg, oh my, something horrible happened. I think I broke it. I think some things are missing. Some links are missing. Yeah, I had a bug in the code. But luckily, I have my skeleton, the hard-coded string that I have here. And I can bring back the previous. So and now this is the previous one with no mistake there. So same as before. But let's see what the problem is. So let's click on this and this and this and this, and now run those codes from previously with the particles and with the segments, and save. And refresh, use skeleton. What is happening? This shouldn't happen. Oh my, this is horrible. Uh, yeah, this is tough. I think something horrible happens here with the looking for the copies, and then the particles need to be first the things that are duplicated, all of them. And then all the segments that contain it, that contain the copy particles, they should be recreated with the copy instead of the original. So it's a problem when you have a segment that is going to come between two copies. That's the problem. Like you define a segment between two copy of the particles, it may find the segment that connects to the other one. And then you get this weird connections between the all the new particles, the copies and the original. It's doing some horrible stuff. So if a copy particle is connected to another copy particle, that should be preserved. But if it's connected to something that doesn't have a copy, that should be... This is complicated, too complicated. No, we don't do it like this. We don't. I know what we do. We remove this code. Couldn't figure it out. Instead, let's just reload this and actually go back to the previous, because now these are some weird duplicated stuff there. Now it's good. And what I'm gonna do is I'm going to keep just the legs here. So this goes away, 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 goes away, goes away, goes away, and so on. And this one here, it's actually not in the skeleton, so it's okay. And now I want to get these particles from here. So let's go here and do this. But instead of this, we say skeleton editor. So I'm gonna copy this in the console. I will also undo this back because I don't want to change the code. And here I have to save connections and particle locations. Okay. And now this loading, let's store it actually in another thing, like not skeleton, but skeleton, not copy, but extra limbs. Okay. And now we have two things in local storage. When we refresh, we have the same as before, but now if we load, I want to get just these extra limbs here, like so. And then we get particles and segments. Like this. So these are the legs coming from here, and I will undo this code. It's just some quick thing I did to be able to get it nicely. So now we have particles and segments here, the copies from previously. And what I'm gonna do is I will say skeleton editor It's tricky. It's gonna be on top of each other and it's gonna be difficult to edit. Let's see. Skeleton editor particles is equal to skeleton editor particles concat particles, the new thing that we got just now, and same for the segments. Like this. So now when I do this, these are duplicated, the legs in the back and the legs in the front. This is good. But they still need to be connected to these things. So all those connections need to be preserved. And I think that I can try. It doesn't work. It clicks on the other one that I don't want. But I have an idea. Let's save what we have so far. So like this. And now these are definitely duplicated there. If I move this one here, I still have the other one below it. So this seems to have worked just fine. But now for those connections to work, what I have to do is here when we calculate the distance to the nearest particle, we are going like that. But if we find the same distance again, I want to overwrite. And I think this is going to give me the other point in all cases because of the ordering. So let's try to refresh this and do this again. No. Well, let's try to go here. Like so, and say P is particles of I going in reverse order. No, it doesn't work. And it doesn't work because the same segment, because the particle equals is based on the location of the particle and not, now we have particles that are exactly at the same location. Okay, these are here in the same spot. I'm just gonna move them a little bit, just a little bit. And now something is working. Okay, I'm not sure if this did it, but one leg behind there is is going away, but it's okay. the one in the front, both of them are attached. So let's do the same also for the one in the back. I actually don't need to move these other points here because we never connect them to anything. I don't know why I did it. These ones here. But now I'm doing it. And here, these. Okay, let's save this again. And now refresh. Use the skeleton and yeah, now the leg behind is also going. Something. The behind leg is moving very badly. But now we can also do this other thing. Move the front leg on the other side in a different way. So in the skeleton here, we have back top and front top. But now we have front top. I imagine these as the right side of the body. And now the left side of the body also somewhere. So let's rename this to front top right everywhere. And let's check if the code still works. Seems like it works. So I'm gonna do the same everywhere. Front mid right, front bottom right, like this. Okay, and now the same here. And because this is 2D, you can think about them any way you want. If one is in the back or whatever, it won't really matter. But we're gonna need copies for these. And front top right is this 25, 24, 23. So was it this or this is now 73. $16. Okay, so this was 25. And now this new one here is 82. So with left here. Okay, this becomes 82. And the other one, 24, 23. Okay, that's the diagonal 24, so 81. I have to move these around, otherwise I click on the wrong thing. So this is 80. and it creates a new segment. So 23 is 80. Okay, and actually these min values here, they are the same. It doesn't matter if it's right or left. They are just in reverse. So what we do here is basically remove that. And here we get that. And here we get that. That. I'm just going to remove these other ones for, let's leave them there. And let's do the front top right, but also left here. And this is going to be 1 minus front spread there. Or let's leave it like so and have here max min instead. So reversing that. And max min with the front, mid, left. Back top right, back top left with the max and the min. And let's see what happens. Wow. Okay, actually back now. Okay, it's a good news. I mean, bad news that this thing broke, but look at this. Front legs. I'm not sure when the stream ended, but basically I'm doing the same thing for the other leg here. So now we have front top right, mid right, bottom right, and left with the different segments that I added through the copy. And here, front top right is like that, top left is like that. Only difference is this max and min are in reverse. I didn't put one minus here. That would have been also an option. And here, same for the front mid right, front mid left. I think I will remove whatever things we were doing with the bottommost bones there. And now I want to do the same for the back top right. And yeah, so in the back there, something happens in the back as well. But let's see, because maybe this is still good for the back segment. What happened? Ah, back mid here. Oh no, this is some horrible. Well, let's see. Let's do exactly the same thing with the back top left. but max min and back mid left max min, and I have to figure out what those segments are to define them here. So the new ones, previous ones were, I think this is not used at the moment. Yeah, so 3, 8, and 12. Let's move these aside a little bit like so. And now these ones here a little bit. So this is 61, 4. Okay, we didn't use 4 anymore. We used, no. 3, this one. So equivalent one from the other leg is 60. So 60 here, and this is back top left. And left and left. And let's see what the other ones are. So 8 maps to this diagonal, so 65. And the last one, I think it's the last diagonal there. 12, yeah. 12 goes to 69 here. So let's see now the rear legs. Oh no, this is not good. Yeah, that's something. It's like a dog sitting. Yeah. Not yet. It's funny. The front legs, I think, are good. So we got that right. And the rear ones, I don't like. Something is horrible, really horrible. Maybe we try 1 instead of 3. 1 and 1 and 58. And reverse these. Back top left. No. Okay. No, ugly. Doesn't go good. Was it this diagonal in use here? 65. 65 and 8. Maybe that needs also to be in reverse here. Let's try. Back mid. No, this looks like it's going backwards. It wants to go backwards. It's so funny. It's it's moving backwards. No, no, not good. Um, let's try 75 and 90. 80 and 90. Doesn't look good. Let's try 64 and 7 instead of 8 and 65. That's potential, but it's too long. So no, and reverse 80, 70. Okay, this is something that is workable. Let's save this new configuration. Something is still very broken in the back. I think these could be also more like that. Mhm. And let's cap these values. If it's more than 0 and 1, let's keep them there. Now, not so much crazy stuff happens. But I don't like these back legs. It's sure we can do better than this. Yeah, it's something. I'm using this open broadcaster software and some plugins for it. I don't remember the name, but I also have my own kind of setup there. Like a bit of my own code that does it. It's a bit glitchy. It's not the best, but it does the job. If you look up things like that, automatically switching windows, I think you can find related to OBS. Maybe someday I can make a video about my exact setup, but I have such a mess recently that I don't even know how to do it at the moment. This is new. Front legs are just fine, but the rear ones... Some complicated stuff happening, and not all of them extend in the same time. Yeah, but let's try. I think the top one could be 55 to 80. Mhm. 55 to 75, maybe. Okay, and the middle one... No, crazy. I really stopped being able to explain what I'm doing. I'm just playing with the values. Yeah. The back, the bottom needs also something. And it needs this thing to grow. So 68 and 11. I don't know how big it is, but oh, okay. Mm. 74, so that's the mid value. So let's put here 80 and 70, and if it doesn't work, we reverse the values. I think we reverse the values. No. Let's try bigger values, maybe 90. Oh, I'm using the wrong, this back mid instead of back bottom. No, this is horrible code structure here. I should have done some array stuff. And then I only would need to worry about the order on the top, and this would be a giant loop that goes through everything. But I'm tired and I don't think anymore so well at this point. Okay. This is hopeful. Mhm. Okay. It's something. I'm really happy with the front part. Like the front legs really move well. The rear ones, it's a different story. Yeah, bending the knees. We tried to get this kind of action here where this leg is kind of really changing this angle here from here to backwards like that, but I just can't get it proper. Yeah, it's difficult. I think it's getting better, but it's too long now. Let's save this. Boy, why did I save this? Okay, this one is too short, so maybe 55. Okay, maybe we're done with this. It's a bit too high up um, in the back. I'm gonna try moving it like this. And let's save it. Yeah, it's too high up in the back. Mm, Yeah, it's something. Hello, Matti. It's tomorrow, but thank you. Yeah, the back legs don't look good at all. It's lifting the leg up too much in the back, like that. Way too much. Hmm. Okay, yeah, that's fine. I'm happy with this movement. Mm, I'm not gonna spend more efforts on this. I still have a little bit of time, and maybe I just do some drawing that makes this look like a, I don't know. Let's do the moose. So I'm gonna take a screenshot from here. I'm gonna go into PowerPoint. Gonna keep this one here as a reference. Let me just zoom to the important parts here. So this is as a reference, and also my skeleton from here. It goes here like this. That. So I'm just going to do some simple drawing on top of this. Keeping this idea kind of, not exactly, but at least the body I want to get it done. And then maybe the legs I can do as well. I want to get this hump here behind the back somehow. Okay, something like this for the body. Now these curves a little bit. Okay, and color. I guess this is the color it should have. No outline. Now some details here, like the ears. So, and these antlers there. I guess this is good. Something like that. And some eyes in the front. Yeah, something like that. And for the legs, we have 3 segments there. And I think I'm going to make them very simple somehow. Let's start with the circle here and edit the points so that they look kind of like my skeleton. I don't use the image reference anymore because our skeleton doesn't look like that skeleton and it wouldn't help very much. So this is the top part, and like that. Oh, wait, it's there. So, something like that. Okay. Yeah, let's see what the colors were. So let's say here in the top part we have some lighter brown, no outline. Then in the middle, some darker brown. And the bottom part, let's have this gray color. Like that. So this is our drawing, and now I don't need those other things anymore. And I'm just going to export these as simple images there. So let's say save as picture, and you probably don't see this part because the screen recorder doesn't take it, but hmm. Yeah. Mm. I'm taking each of them and saving them as individual pictures. And now they are here in images. Or no, they're not. Now they are here in images. So we have the body and the different parts of the leg appearing as images there. Let's load them. Body, new image. like that. And front, the same 3 things there. So these are images there, and like that, we reference them. We give them the source. Like that. Okay. Code still works, and in images we now have different img values that we can use to put on top of our characters somehow. And let's begin with this body, and I would like to put the body somehow, I mean, according to the orientation of this giant blob here. So maybe I'm gonna take as a reference this point from here, and this other point from here. Let's see, I don't have any more of those points. How did I do that before? I should have saved that. Unmouse up here. Yeah, but I need the index. I don't think it works with find. Damn. It was like that. Okay, so 17 and let's say 26. 17 and 26. I'll just update this skeleton class. So here, draw on the CTX, and this is going to draw the skin. So draw skin 17 and 26. So body back is particles 17 and location of those, and body front, it's with 26. So now those 2 things tell us how to draw the body of the thing. So These are global variables now, these images. Mm. And I'm gonna put it at the average location between these 2 points. So let's calculate the average location between body back and body front. Like this. This average is gonna be a function we have here in math, similar as these ones, but for points. So instead of adding, we just take the average where we add the coordinates and divide by 2. Like so. And in our skeleton, like that. We have to also draw skin. So we go back into our animate and let's say skeleton editor, draw skin CTX. And now when we refresh, draw skin is not defined because it should be from skeleton. Okay. Oh, it's something there. I think that's the top left corner. So this draw skin takes the top left corner and puts it there. Puts it here, probably. So draw image. I think it has many ways of calling it, and I don't remember. There are here. Let's try putting here 150. Now it's this small one here. I guess this has a size. It's actually the distance. So from body back to body front. So this distance tells us the width of this drawing here. Like that. But we should also subtract here that. So left is average x minus width divided by 2. And this is where we want to start our drawing. Like that. And the height here, I'm just gonna eyeball it. I don't have the patience. I would need to get more particles. Or it's not that hard. It's the distance from 23 to 20. So body top, body bottom. 23 to 20. and height is gonna be that. And top is going to be like that, and it goes in here like so. Refresh, do that. Something's wrong. Well, actually, these antlers go above the body, they're somewhere higher, so this is not the best thing to do. Yeah. And this is supposed to be height here. I think my mouse battery is running out. And top, this is where it should start. Okay, this is good. It has kind of the same height, but not good. Because these antlers are so big. I think it's just, I'm gonna double this distance. And there is an offset happening here, so I guess this is good. Now it's jiggling a bit, the body of this thing, and I want it to keep the angle of the body. So it's not happening at the moment. It is following the skeleton, but I would like it to, like, now the back part is going up and down and up and down, and this thing is not orienting itself like that. So I want to do that as well. I think it's gonna work like this. So you get the angle, and then we save the state, and we translate to left and top, rotate by this body angle, and we remove left and top from here, and then restore so that problems don't happen on the next iteration. Body is not there anymore. Okay, it's somewhere way at the top there, and it's upside down. That's a new one. So we translate it here. Oh, um, ah, yeah, there is a problem. So Okay. I think we want to translate to the average x and y, and we want to use minus width and minus height, whatever there. Something. It is rotating. And there it is. So now it's resembling the skeleton rotation there. Okay. The legs, I really have doubts I can do the legs. But maybe I can. Last effort. Let's try to put the one here. I'm actually interested in the average between 36, 37 and 39, 38. So the middle here. Actually, we'll do the whole leg at once. So 36, 37. The average between these is the top part. Let's just call this BR1, BR2, 3, 4, for back right, back right, 1, 2, 3, 4. BR1 is that thing. So 36, 37. And then 39, 38 is going to be BR2. Like that. And then BR3 is going to be 41, 40. And finally 42, 43. So this is back right, 1, 2, 3, 4. And we also have one in the left here. So we have 8 and 9. So let's copy all of these. These will be back left. So 8 and 9. And 10, 11, 12, 13, and 15, 14. 15, 14, like so. So these are back points. And now the front, same kind of strategy, I think. Let's separate them a little bit. Yeah, definitely this stream became very hard to follow after some time, but it usually happens when I become too tired. And 0, 1. Front left 0, 1. And then 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. These were the first ones that we made there. And now we copy this for the front right. And they will be 28, 29, 30, 31, 32, 33, 34, 35. So 28, 29, 30, 31, 32, 33, 34, 35. A lot of points here. And now we have to draw between this one and this one. We have to draw the leg back top, basically. Salut, Răzvan. Yeah, legs will be the same. You need to give them some coordinates and you need to give them some orientation. Actually, to get the center point of the leg back top, we need to average also these two now. So, yeah. Let's see. Let's copy this part here. Probably it's going to be useful. Average, then the distance, then there is something, then there is an angle between those two things. All of this code is actually very similar. But there are some annoying hard-coded things there that we did for the height of this thing that didn't match there and stuff like that. I'm just going to copy this and then see if we can reuse it somehow. But basically BR1 and BR2 will be the top thing. And the distance is the distance between these. The width, actually the height will be this, and the width will be something probably scaled somehow. I'm just gonna leave them like this. And these variable names are already given, so I'm gonna give an underscore here, and let's try this. And here we have underscore average, underscore body angle, underscore width, height, width, and the height. And the image that we draw will not be the body, will be the leg back top. Like so. Okay, it's not, it's again the body. What happened? I guess when I load the images, I load something funny here. Body twice. So something is here now, but it's not rotated the way I expect. And that's because all of the things that I'm drawing here, like this has been oriented like that. This needs to also be oriented like that. And that. And that. So that all of them have the same orientation. Here I basically just put them on top of everything, but that's not the proper way to handle things. And now PowerPoint is so annoying that it's gonna make this have a weird background here, like the height of this image will include this part. So I'm just gonna paste everything as an image again, and now this won't be a problem anymore. So I copy, paste everything like that as an image. Right click and there is an option there, paste as image, but you probably don't see that part in my screen recorder because right click menus don't show. And now with all of these, I'm gonna do the saving again. And everything is gonna have now this same orientation. And now, if we refresh this, I think this is okay. Probably could be bigger, but it's definitely appearing there. I think I don't want to draw anymore the skeleton. It's gonna be confusing, too many things. So here in the draw, in the animate, the physics update here. It's better. Yeah, and let's do the same thing with the other ones. So I'm gonna make a method here, a helping method, draw leg part. And I'm gonna give these as anchor points. Anchor 1, anchor 2, and the image itself, this IMG. And let's copy this, everything here, and replace BR1, BR2 with anchor 1, anchor 2. Like so. And IMG with this. And here we say this draw leg part BR1, BR2, images, leg, back, top. And if we do that, it probably gives us an error. Oh no, it works. Okay. I thought the CTX is not there, and it's not, but it's a global variable, so it works. I don't like global variables, so I'm gonna pass here CTX. And it should still work. Right, so now we have this. Let's try BR2, BR3 with leg back middle. Right. This thing here doesn't look good. I think something is wrong, messed up with my orientation. Let's figure it out after this is done, like all of them. And 3 to 4. So that's for the leg back, for the back right. So this is in front of the this body. We also have for back left, so this R turned into an L. And something is really messed up here. It's funny, but not funny. Yeah, I think I'm loading a... Oh, okay. Bottom. And the width is not adjusting properly, so I have to work with that. And this is now, both legs are drawn in front of this body. So that's one other thing we have to fix. I'm just gonna paste first for the front. For the front, and here that. So now we have that. And we really need the left legs to be behind the body itself. So I'm just going to take the body here. Put it here. And now when moving, like this leg here in front, it's obviously behind the body there. But not that obvious. Like, I regret not having there some kind of shadow or something. And I really don't know what's up with this one because it seems to be upside down here. I think here we may have to play around with these. Maybe something like that. But the width and height just doesn't work. Because the proportions change when we deform those ligaments there. Yeah, separate body and antlers, that's a good idea. It wouldn't have, if the head would be a different thing. Very good idea. But I'm tired, so I just want to wrap it up in an ugly way. I'm gonna end soon. So, okay, something like that. Maybe this back of the elk should be bigger as well. Let me modify here the points a little bit. That's better. But now playing with these widths and heights. So for the bottom part of the leg, like these, the bottom parts, um, they need some special width there, maybe 30 only. Okay, not width, but height. I think the orientation is somehow messed up and huh. I don't want to replace both of those things. I just replace here height with width and put here 30. So now that one behind is becoming good. Or in front, actually. Yeah. I'm gonna add to everything a little bit of glow. Little bit of a glow. To have a kind of a contour there. A quick dirty fix. And now I save the things again. Maybe it's not a good idea. Let's not do this. Mm. Oh, I already saved over it. Yeah, bad idea. I prefer it this way. This is much better. But still some things need to be changed here. So this 30 looks good. We have to put it also here. Both of them like that. And the width here needs to be definitely bigger. So maybe 100. So messing up everything. What? No, width is after the height now. Oh no. Yeah, something like that. But then these middle sections, I think they are too wide now. Let's see if we can get away with 80 width and height here. I think that's fine. And now for this midsection, let's say 60 and 70. Same here. Looks good. Well, a little funny, but not bad. Let's put 60 and 80. And maybe 85 here. Yeah, that's really good. And here also in the front we need something. I'm just gonna try my luck with these same values and see what happens. And looks like I was lucky. Okay, now I don't need to draw that skeleton anymore. And I think I can quickly hide it by just putting here clear rect after this, which is really unconventional. But there it is. It's something. I'm happy with the result. I mean, it's more about the technique and not really about making something super fantastic. Uh, and let's call this use skeleton by default so that people get it already. I will remove this button, but those who have watched know what it is. Yeah, it looks kind of weird. These are too long in front. So I'm gonna make them be just 90. It's better. 85. Like so. And here the ground, I want to draw it before everything, and my mouse battery really decided to stop working now. So the ground here. Yeah, this. Mm, Yeah, just making it look a little nicer there. Okay, I think I'm done. It was funny. I'm not done. I want the. I'm done. I'm done. I would have wanted the canvas to follow the moose, but if I make that happen now, there is nothing in the background to make it look like it's going somewhere, and I would need to make stuff in the background, and I am tired. So this is it. And let me just put the code also on the website there. I will disable that editor actually. The skeleton editor. Because people clicking on it may not know what is it about. So I only add the event listeners if it's enabled. And then here, when defining the editor, I will say false. So yeah, clicking doesn't do anything anymore. And let's just write in the top left corner. Or below the canvas. And I would like the moose to be more to the left here. So let's actually translate this canvas a bit. Mm. other direction. And yeah, okay, that's it. I'm done. Any last minute comments? I had fun today. Seems like the images don't load. Okay, for some reason it doesn't work. Let's store this skeleton back here and I don't want to lose it. Okay, seems to work also without local storage now. So okay, it looks like it works. You may have to do local storage clear in the console in the browser, because if you made some skeletons before, um, they will maybe not be compatible with the one that comes hard coded here in the load function now. So final link here. That's it. Hope it was fun for you, and as it was for me. Yes. If you wanted to go crazy, you can go and in the skeleton there, we're using this lerp there, and we're capping it from 0 to 1. I think that we could use -1 and 2 and have some fun with it. So I was focusing on making the walk realistic somehow, and now we get this kind of weird contortionist moose. um, you can still walk with it if you know what you're doing, but basically we make the spread between the legs much larger now, and it's kind of like uncharted territory with changes like this. Anyway, um, whoops. Yeah, whoops, whoops, whoops. Okay, okay, careful, 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 careful. Okay. Oh, no, 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 no. Okay, okay. Yeah. Now, oh, it's coming back. Okay, something is wrong. I still have the debugging in the console. Anyway, that's it. Thank you all for watching. It was fun, I think. Ah, yeah, I'm not going anymore. I'm done. Yay, real dedication. Yeah. No, I don't speak Arabic. If it's not showing for you, try going in the console and typing local storage dot clear, because you may have the skeleton from previously and it may not be compatible with that. You can also try refreshing with F5, Control F5, clear the cache if necessary, because there may be some code remnants from a while ago. So, yeah, I think that's it. Thanks again for watching, and I'm gonna close the stream now before YouTube decides to break it again. So, yeah, that's it, and see you.